All right, what's up, everyone? We're back for another Polymath online salon with our usual suspects. We got Alon, we got DVZ from the lab back in Florida, we got Jesse, we got Willem, we got Dugan, and we may have a couple other people also join on later on. But today is going to be a time for Professor Alon Barenholtz to give a quick presentation and then potentially a hopefully insightful discussion on his autoregression model of cognition to understand things about working memory and short-term memory, long-term memory, how those interact with certain diseases, because I actually think his theory has a lot of application for neurological conditions. And yeah, so this is going to be exciting. And to start off, let's get quick intros from everyone. Alon, you first.
Hi, everybody. Elon Barenholtz, co-director of the Machine Perception and Cognitive Robotics Lab at Florida Atlantic University. And yeah, working on this, what I think is an interesting possible new angle on thinking about how cognition works and more recently, how it might relate to thinking about disease, specifically with disease of memory.
Yeah, hi guys. I'm Willem. I'm from the Wolfram Institute. I'm doing research on computational biology there. Happy to be here.
Howdy, I'm Daniel. I am a PhD student under Dr. Alon Barenholtz. In general, I'm interested in making AI smarter to make humans smarter. I'm doing this in my research with Dr. Alon by building a system to automate neuroscience research. And I'm doing this personally by building a better system for knowledge workers to organize their knowledge.
Hey, I'm Jesse. I'm a data science student finishing up at UC San Diego. I've done a fair bit in startups and other research spaces, and I have a particular interest in some things around cognitive science and phenomenology, a little background there. So I'm looking forward to today's talk. Thanks.
Dugan Hammock. I'm a research coordinator at the Wolfram Research Institute. Background is in mathematics, geometry, and aperiodic Heiling's four-dimensional visualization. I'm interested in everything related to perception, consciousness, and the biology of knowing things.
Awesome. Yes. And several of you were actually special guests at the Polymath Medical Salon the other week, which is exciting to have a good bridge between the online and in person. Dugan, Willem, Alon, DVZ, they were all there, and it was a lot of fun. But as for me, yes. I'm Addy. I'm founder of Ekkolápto, and I have many ideas and things in cognition and biology and how they relate to each other. The way these days I've been summing things up for Ekkolápto is that my goal is to be able to enhance the inherent capabilities of the mind and the body to better understand reality, which is kind of where I sort of look at the brain and the rest of the body as a kind of diverse intelligence and stuff like that. But let's get started with Alon's presentation on autoregression.
Cool. Okay, great. So probably shouldn't have started with the slide, which is the model I've come to destroy. But so be it. This is kind of I would call this, in some ways, this sort of the conventional view of the way our cognitive, at least memory system works. I would like, over the course of this conversation, to propose and to kind of explore the possibility that it's not even necessarily specific to memory, but we'll get into that. But I want to just kind of start off with what I think of as sort of the current, I wouldn't even call it orthodoxy, because it's so unquestioned in some ways that people typically don't even take time to examine the underlying assumptions. But I think it's time to radically investigate and to question those assumptions, and that's basically the goal of what I want to lay out briefly in the next few minutes. What it would mean to reevaluate and rethink what it means to remember and to know, and for that knowledge and memory to guide behavior. So the conventional view, and I'm probably not really doing it justice, but I just want to kind of lay it out there, call it the straw man version, but I don't think it's such a straw man. I think this is kind of a tacitly assumed perspective is that our brain holds within it facts, information that's stored, and that this information, facts like what certain facts about the world, what's the capital of France, or what does your significant other look like, how do they behave, what's their personality like, what's your personality like. Basically, all the information that we have that we think of as bringing to bear into our regular everyday cognitive lives is typically thought of as essentially being stored in our brain in, I guess you could say, static form. And when we are behaving and using that information, we're going into the archives and pulling it out and using it, retrieving. So it's typically called encoding, storage, and retrieval is sort of the kind of mantra of what memory is in cognition. It's what I teach. My slides are still full of these things, and I'm having a little bit of a crisis, wondering what I'm going to do. I'm not teaching this semester because I'm on sabbatical, but by the time I spin up these slides again, I'm not going to believe in them anymore. And so I'm trying to think about how to actually navigate what is the conventional view is encoding, storage, retrieval model, which is basically the information flows into your brain in some form. That's sort of a dynamic flow, and then certain facts about the world, certain kinds of information are retained, and sometimes they're retained for a very brief amount of time. So this is the Atkinson and Shiffrin model. Why don't we do it in relation to this particular diagram? Atkinson and Shiffrin is well over a half century old. Baddeley working model. Memory is kind of an updated version, but they're kind of very much even the Baddeley working model is just an updated version of this core idea. And so the idea is we've got these memory stores. So you have a sensory store, and this is based on early work by Sperling. The idea being that you've got actually the sensory stimulus sort of stays in your system for 1 to 2 seconds. And so you've kind of got like the retinal image that's just sticking around, and you can theoretically do things with it. Under the right experimental conditions, you can be observed to actually engage with that short-term memory, sensory memory store. And that's tricky. It's very hard to access it because it lasts for such a short amount of time, according to this theoretical perspective. And then we have what's called working or short-term memory, which lasts 15 to 30 seconds. And this is supposed to be the workplace of cognition, but it is also a memory store. The idea being that if I, for example, say to you, repeat back a sequence of digits or letters, A, G, L, M, O, P, R. Okay, can you repeat that back? No, don't actually do it, but imagine if you had to do that. The idea is that the information is still kind of bouncing around in some form, and if you so choose and desire for some behavioral in order to guide some behavior, you can go and retrieve that information. So the sensory store is harder to retrieve from. Typically, the sensory store is you drag the information sensory store into working memory because this mission will self-destruct. It's self-destructing very quickly, but it's still there. And again, I want to get to this point. I want to kind of pinpoint that there's this kind of implicit notion that information came in and it's still there. That there's actually sort of actual retention, encoding, and storage of the information as it came in. And then in the short-term memory, you've got a somewhat longer version of sensory memory. The information's still there, kind of in the way it came encoded. So it'll have things like the actual specific exact words or letters that have been that somebody has just recently said to you or that you thought about, and the order in which those were said, and even things like pitch and intonation and all of that. And the idea is that it's encoded and stored kind of in, again, the same form, that the way that you've processed that information and perceived that information ends up being in a sort of static way preserved. And then if you so choose, for some behavioral reason, you can go and retrieve that information from working memory. What kind of example would there be? Well, the classic example is sort of the short-term memory experiment, where you give people some sort of sequence. It could be a visual sequence, it could be an auditory sequence, it could also be a visual sequence or a visual stimulus. And the idea is people are able to, and this is not debatable. People are able to, if you give them that task, they can go and repeat the information. And in this case, like for the classic auditory memory, you can go and repeat the sentence that somebody said to you using the exact words, right? And people are able to do this, and they're able to do this for somewhere between 15 and 30 seconds. Lots of complexities about rehearsal and things like that we won't get into. But the basic notion is that there is this buffer, a sort of a static buffer where information lives for a certain amount of time until it doesn't, self-destructs in some form. And while it's still there, you're able to retrieve it and use it for some sort of behavioral output, like, for example, repeating something. Then there's long-term memory, which is also viewed as a much longer-term storage buffer where there's different kinds of information. There's semantic information, facts about the world. There's episodic information, which is actual memories that you can kind of time travel, which is sometimes called mental time travel. And the idea is, again, that there's sort of stored memories that you can, under the right conditions, retrieve. This is typically thought of not as an active workspace, but a place that's kind of cold storage, holding information. And then the active process can go and retrieve that information, bring it into working memory, the working space, and hold it in memory there, and then you can do stuff with it. But the overall theme is one of these kinds of memory storage units that are encoding information, after information has been encoded from the world, it is preserved in the form in which it was encoded for a certain amount of time. Long-term memory ends up maybe abstracting the information away from the original form in which it was encoded. So you don't remember, for example, in long-term memory, you don't remember the exact sentence and the exact words. Instead, you remember things like semantic facts that are extracted away from the particular sequence as it came in. But in any case, these are viewed as essentially storages of facts or information about the world. And one way to think about that, and it's the idea that I want to kind of push back against, is that if you were a sort of a extremely well-funded neuroscientist who has the very advanced techniques, maybe this is sometime in the future, and you can really read off the activity of every neuron over a certain amount of time. The idea would be that you could actually find these facts somewhere in the brain. I could go into short-term memory and I could find, here's the sequence that you just heard. Or I can go into long-term memory and find, here's the capital of France. It's encoded in these weights, and they'd be in some ways readable as distinct pieces of information that capture something about the world, sort of about the external world, and we can think of that as being a referent. Now, don't want to get too deeply into that about sort of external reference, but I think to some extent that captures a general intuition that most people have, including neuroscientists, about how the brain functions. There's different memory stores that are working together. They're distinct from each other. They have different storage capacity and different types of information they carry, but they are essentially storage units. So what I am claiming, and this is sort of the broad claim I'm making, is that there's really no memory per se. There's nothing like facts about the world inside the brain. What there is instead is potentiation, that we now have our models, like large language models, that are able to generate information, generate meaningful, in this case, linguistic outputs, but they can also generate, multi-model models can also generate, say, things like video sequences, that can give the appearance that these systems know something in the traditional sense. But in fact, there really is nobody home in a certain sense. There's nobody home. I don't mean to get it. I'm not talking about at the consciousness level, although I certainly think this has very strong relevance to questions about consciousness, something I hope we can get into in this conversation. But what I mean to say is that if you are if you are a perfectly omniscient neuroscientist, but what you're dealing with is a large language model brain, and you go and look at the weights in the large language model brain, you're not actually going to be able to find any facts. The facts don't live there in a static form at all. So here's just a example that I used in a recent talk at the MindFest conference that we just had. I used it for a different purpose, but it serves the same idea. So I told the Claude in this case, I think the prompt was something, give me a first-person vivid a description of, with lots of sensory details about what it's like to bite into a juicy orange. And, here's Claude's output. I can still taste it, the way the skin tore under my fingers, releasing that sharp citrusy mist that clung to my hands, sinking into my skin. The scent alone was enough to make my mouth water, bright sweet with that faint bitterness from the oils in the peel, which, first of all, is just pretty impressive. Maybe not as impressive now as it was a year and a half, 2 years ago, when it beyond blew my mind that these large language models could do something like this, could do something so compelling. But here's the the kicker is that, of course, Claude certainly has never tasted anything. It doesn't know what an orange is from a visual or a tactile or an olfactory sense. That information is not in there. But even more importantly, my prompt caused this model to generate this output. And you might think, well, that means it knows about things like citrus and what kind of features the citrus has, because it's able to produce this output. And in some sense, operationally, I would say that's the definition of what it means to know that this is the case. So this thing seems to have facts about the world built into its system. However, if we just dig in a little bit into what is actually going on in a large language model, there are in fact not really facts in the system. Certainly not long-form facts. What kind of facts does an autoregressive system know? It really only knows one thing and one thing only, which is how to generate the next token from an input sequence. So just to quickly run through this, what an autoregressive next generation consists of, this is my own acronym, ARENT. I'm being a little cute with that because my point is these aren't facts about the world. They are just autoregressive next tokens. And the idea is what you've got is a trained model, trained neural network, and that's your function. And you give it an input sequence, like, for example, the sequence could be, provide me with a first-person vivid account of what it's like to bite into an orange. And what the system does is it outputs a single token. And a token, most of you know, can loosely be thought of as like the next word. It's not exactly a word, depends on your tokenization scheme. It's just, but one way to think about the terminology is the token is a numerical representation of your chunked up inputs. You've got a model, you've trained it on a whole bunch of data. In order to do that, you have to turn it into a sequence of stuff, sequence of things, and we call those tokens. And loosely speaking, they kind of correspond to words in many cases. So for just purposes of reduced jargon, let's just think of the output as being the next word. And so we've got an input sequence, which is the prompt. When we use chat models, we give it a prompt, we ask the question, and what the model does is then just produces the very next word. And then what it does is it takes that word and sticks it onto the sequence. So now you've got a new input sequence, and so because it consists of the entire prompt plus whatever output the thing gave. So in this case, the next word would be I. So I should have had the prompt here, sorry, but let's say the prompt was give me a vivid first-person sequence, a first-person account, whatever, and then it outputs I. And that's all it's got right now. It doesn't, should be very clear, have a plan. And it doesn't have a long-form version of what it's going to say. It doesn't have any capacity to do that. Computationally speaking, all it's able to do is take in an input sequence and produce the next token. Now, what happens, of course, is you then take this sequence, put it through the system again, the very same function, it's the same trained model, and it produces the next guess. So in this case, it would be can, right? I can. And so it produces can. Now we've got the whole prompt plus I can, and it's going to keep on doing this. And this is what autoregression is. It's this run an input through a single forward pass model. So it's just a function that just produces one output. It doesn't have to be, not all autoregression has to be, by the way, a single sort of one-dimensional output. This isn't one, it's not one-dimensional. It's not the right way to think about it. It's a bunch of numbers that represent this token. So it's not even one-dimensional, but the point is it's putting out one thing, one output. And then that output goes back in somehow into forming the input, and then you run it again. and it's a dynamic system. It's a dynamical system. It runs actually in this kind of iterative loop recursively, and then as you run it, in the case of large language models, it produces long form responses like this one. So once you see that that's what's going on, and let me just actually, I think it's actually useful to just walk through these other examples. So this is the Fibonacci sequence, and it is also an autoregressive kind of process. You take the last two numbers and you add this together and you get the next number. And so here we would take a 1 and we get 1, and then so now we have the last two consist of 1 and 1, and then you get 2, and so that's 2 here, and so on and so forth. And this, if you run this in sequence, what you've got here is a very, very dumb system, because all it has to do, you can build it really easily, right? You could almost build it out of Tinker Toy. So you can build it out of a mechanical system. It doesn't require any great computational prowess to do. All you're doing is you've got an adder, right? You've got a function that does adding to add two numbers, and then you just take those two numbers, and all you need then is something that you're able to store the output, such that you can then take the output of the system, make that the new input. So you've got it, now you've got this new input that consists of the last output plus whatever was there before, and then you run this thing, and it produces a sequence. Now, this sequence, if you wanted to build an actual closed form equation or some sort of a computational process that was to produce this sequence to up to 100,000, 1 million numbers, it would be quite complicated to be able to build out that function. But if you do it autoregressively, it's really dumb. It's a very simple system. In other words, the underlying computation that's taking place here is simple, as long as you're able to do it in this autoregressive form. And so the point here is that you can do the same thing here. So here's our large language models. They're doing something significantly more sophisticated. I'm not going to claim they're adding two numbers together, but what they're doing is next token generation, which requires a transformer model, which is definitely far more sophisticated than adding together two numbers or anything like that. But here's what it isn't. And no matter how sophisticated your transformer model doesn't actually have within it this type of information. That the way the skin tore under my finger is really that sharp citrusy mist. It's not in there at all. The only way that you ever get to this information is by running it autoregressively. You have to run it autoregressively. So the information isn't really in the model. So where does the information live? It's really a longer conversation. My sort of broader take on all of this is that the information actually lives in language itself. That language and the sequence in which language is encoded previously was encoded only in people's minds and in society in terms of how the language, that the corpus that sort of lived amongst people. Now we have a digital corpus, so it lives there, but it's really the structure of language that contains the information about what it is like to bite into an orange, or at least linguistically how to describe that. But I think to me, it's quite clear, thinking about how the autoregressive model works, that the actual information, the longer form information, doesn't really live in the model. It's not actually in the brain. And so this is where I get to my ARG theory of cognition, and being a little bit silly here, but there aren't memories in the brain. There aren't facts in the brain. What the brain represents is the capacity to autoregressively generate these facts. And so it's a very different perspective on thinking about what the brain is doing. Certainly, and when I say the brain, I think I'm not talking about things like respiration and the sort of the sympathetic and parasympathetic responses, brainstem activity, and all of that. I think for now I'm only really thinking about cortex, but that's TBD. But at least things that we call cognition, like reasoning about information, thinking, responding, and maybe we could call it intelligence. But all the stuff that cognitive psychologists and cognitive neuroscientists are talking about when they talk about memory and cognition, all of that stuff. So it is a fairly wide umbrella. And so this perspective is that we don't think of long-term memory as a storage site. Their facts are not in there. If you have, it doesn't matter how good your imaging is. It doesn't matter. You can't actually find the facts because they don't live in there. In fact, what it is just trained parameters that guide generation. It's trained network parameters, just like in the large language model. And so they are just, I think of it as a sort of potentiation that put this, just add water and memories will emerge, but it has to happen in the context of this autoregressive kind of generation process. And then short-term memory in this is just the generative process itself, although there's this residual activation, something that I'm still working on in terms of, and I would very much appreciate kind of how to think about this. But in the case of large language models, going back to this, when we add this output back onto the sequence, we've got the sequence. And in the large language models, this is the context. It's when you're chatting with the chatbot and you've had a conversation, it's feeding in an entire conversation on each pass just to get the next token, the very next word. It's feeding in that entire conversation and then getting the next one. And so there is this kind of, in this case, short-term memory. Although I would point out, it's short-term memory, but it's not retrieved in the way that we think of in the classic encoding storage retrieval. It's just guiding generation. So it's still not memory in the classical sense that there are facts even about the most recent conversation that you're then retrieving and bringing into memory, into the workspace. It's simply guiding generation. I'm working on a model now where there isn't really any explicit representation of the input sequence at all. It's just recurrent activation. But I don't want to get into that. But really, it's thinking of short-term memory here. The important point for our conversation is that short-term memory isn't, again, this sort of static facts that you then retrieve. Rather, it's just guided generation. So when I'm talking to you now, the next thing I'm going to say is guided by the latter half of my sentence is guided by the first half of my sentence, and just like in the large language models, the current output that is guided by the previous inputs and outputs. But again, if we think about it in terms of generation, they're just voting on what you should do next. You're not actually going back and asking. The system's never going back and finding them, meaning the generative system is still just a single pass output from this input. And so it's very different than saying you're actually retrieving that information and bringing it into memory. I could elaborate on that. It seems like a kind of granular fine point, but it's fundamental. It's very essential that guided generation is not the same thing as retrieving memory. So yes, in this model, that's pretty much what cognition is, according to this view, is not a collection of information or facts. Even sensory memory, I'm going to claim is not that you've actually preserved anything in its sort of static form, but rather there's residual activation that is guiding generation. For example, if somebody asks you, what did you just see? You're able to produce a response. But the response doesn't mean you're going back into memory and retrieving it. It means that you're able to produce this. So I just want to give a quick example, and then I'm going to get right into the point of.
Yeah, let's move quick. Actually.
Okay. One little last point, just to drive this home. If you ask an LLM, can you you could try this, right? Give me a paragraph, write a story. It'll write you a nice little paragraph story, and then say, give that story to a new window and say, can you repeat this? It can repeat it verbatim, but what you have to realize is it's not actually computationally going back and looking at that in order to repeat it. It doesn't have access to memory in that sense. Rather, it's just guided generation, and the guided generation happens to repeat the sentence, the thing, perfectly. And so this is the reason I want to mention this, is because it's important to my next point, which is the way we've been thinking about short-term memory I'm arguing is wrong. That when we ask people to recall a sequence and they're able to do it, that gives us the illusion, from my perspective, it gives us the illusion that they've got sort of the sequence is still there. It's, as I said, rattling around in their mind, and they're holding it there, and they're able to go and retrieve it. But from a guided generation standpoint, that's not what's happening. Instead, what's happening is the fact that you recently we're exposed to that information means that it's in context, it's more strongly influencing your current generation. And so the fact that we're able to remember things from more recently is not because it's still in memory, but because it's it has a stronger influence on current generation. So when we look at sort of classic, and now I am pivoting, and just a few more points until I kind of open the floor to conversation.
Yeah, I think we'll have a lot of questions.
Great, awesome. But I want to get to sort of the point of the specific point about memory, short-term memory, the way people conceptualize it, and what it means in relation to things like dementia, and how it's used as a tool for possibly detecting dementia, but how it might mean something very differently than we've historically thought about. So there's this classic sort of forgetting curve. It goes back to the Peterson in short-term memory experiments, where I say, here, remember this, recall this sequence, and I give people, let's say, JGL, and you have to maybe do some other tasks so you're not rehearsing it. And then I wait for 10, 12, 15 seconds, and then I ask you to repeat it. Anybody remember what it was? I'll open the floor. That is JGL. And so the idea is, well, people can repeat those sequences. It's because it's preserved in memory. And to the extent that we start to see a decline, what is happening in that case, according to the sort of the classic, the conventional view, is that memory is slowly getting interfered with and is getting decay. It's decaying over time. So there's this sort of idea of a static representation that's decaying over time. And then by the time you're like 18 seconds out, if you haven't had the chance to rehearse it, it's gone and it disappears. The perspective, according to the perspective that I'm taking, this memory curve has a completely different meaning. It's that information that as it gets further back in the sequence, because you're getting a temporal sequence as you're taking information, it simply has less influence on your current generation. And so if it's too far back, you're not able to repeat it verbatim, because, and just to use the terminology, I know we haven't discussed this in this presentation, but the attention weights are getting reduced dramatically as you go further back in the sequence on the current generation. So the attention weights in relation to what you're currently going to produce and what your next output is going to be. So the weighting, their influence is going to be dramatically reduced relative to words that are closer to the current generation. So in other words, if I say to you, could you repeat those words back? Now, that question, can you repeat those words back? It should guide your next generation, right? But in order to do that appropriately, you need to also be guided by the words that came 15, 20, 30 seconds ago. But my claim is that what's happening is those are no longer producing the same influence because they are further back in the sequence. And so I actually built out a little sort of quick computational model of this so this is not real data at all. It's just a model of if you were to to build an attention model this way. And I know we haven't discussed how attention works, but in a very quick nutshell, it's just saying how much does each word influence the representation of other words in a sequence. So what you could do is you can actually sort of penalize attention in such a way that distance matters. Distance matters in attention for other reasons, and it's in the corpus. It actually shows up, like the things that are further back in a sequence, further away from tokens that are further away from each other, actually have less influence. But what I'm proposing in this case is to model it in such a way that you explicitly reduce attention, reduce the weight on recent words if other words are further back in the sequence. And what you get is a forgetting curve. And it looks very suspiciously like forgetting curves if you just set your parameters appropriately. So you kind of set your lambda rate so that you've got the penalization score for distance. You get something that looks very much like a forgetting curve. So I think that according to my model, this is you'll be able to model the kind of deficits you see just over time. First of all, but I did want to get to this because. As you can see, so what you've got here is sort of normal forgetting, and you can also parameterize this, so you can change this forgetting curve, and what that means is you're just changing the attentional weights so that you can get deficits. You can get significant, more rapid drop off in memory, so that you will see the kinds of things we actually see in, say, the early stages of Alzheimer's disease, where what you'll see is actual short-term memory deficits. They won't be able to repeat back 5, 6, 7 letters or numbers. And my perspective here is that what you're seeing then is actually a decay in the appropriate guided generation, rather than a sort of a rapid decay or interference in the static memory kind of view. So that's the long and short of it. Sort of my overall perspective, how I think it's kind of radically different from the way memory, both short-term and long-term memory, are typically thought of. And then more recently, and I mean this, very recently, I've been thinking about how this might have some application to thinking about things like memory loss.
For me, being kind of from the field of being interested in cognitive enhancement, which is sort of, as more and more people listen to this, you're going to see that's a lot of what I talk about, right? I'll often kind of say that, what you see is what you get. The lens at which that you view things through is going to very directly shape what you actually observe and perceive. And another saying would be for that is like, if you measure in inches, what are you going to get? Inches, right? It seems very, very obvious, but that's, I think, a very interesting idea about how we measure and observe things in the first place. And when I think about memories, what I think a lot about of the interpretation of memories, the lens of those memories, right? So like if you think about in a functional perspective, when I think about memories, is that if I'm having a memory for something, can I memorize and quote unquote store the information, right? Even though you'll have maybe a disagreement with the word store, what way can you store and process that lets you do the most with it, right? Because you can have a very specific memory that's good for maybe one or two things, and then you can have a memory that serves more benefit. And then I also think there's, and this can also go into sort of the neurological health thing about PTSD. I think a lot of that is you're basically overfitting. Like you're sometimes you don't want that one lens to be over applied to everything, and so that if you have some form of a trauma thing or whatever, is that any little thing that even remotely closely fits your experience, it's going to trigger something, which is your mind trying to keep you safe. But it's like it's like an autoimmune response almost. The immune system is overreacting. I was curious if you've thought about that at all, about PTSD.
I have not. And the fact of the matter is, I've been so sort of deep in the bowels of thinking about this theory from the perspective of just validation and to what extent it can account for sort of classic canonical perspectives or observations like the empirical data, that I haven't really spent enough time yet thinking about even things like I was mentioning, even things like dementia. But I will say that it's a fascinating point in that what happens in PTSD, I can almost call it a layperson's knowledge of it, is what you're getting is unwanted generation. What's happening is that the mind is kind of is outputting imagery or sounds that you don't want, and I don't know to what extent thinking about it in terms of guided generation might be a clue, as opposed to say, so one way, right? They're sometimes called intrusive memories, right? So what is an intrusive memory? So in my view, right, intrusive memory, in sort of the classical view would be there's this kind of there's a stored video in there, and for some reason your mind is freaking pressing play again and again. And you wish you didn't. And if you could do, Eternal Sunshine of the Spotless Mind, you could go in and erase that memory and it won't generate it anymore. Or maybe you overwrite that memory. That's one way to think about it. In my perspective, that's not the framework is not to view it as a sort of a stored memory, but rather it's a stored behavioral tendency to do a certain kind of generation. And in this case, it's a generation that causes you distress. And so I don't have, certainly haven't thought about this long enough to say I have a clear idea of how that might change how you think about treating it, but it is a different framework. And so, give me an hour and I could come up with, with probably, an ungrounded kind of perspective of like how you might think about it differently. But I think it should be clear that right off the bat is that thinking about memory in this way maybe could provide different kinds of insights into what's going on in the brain when you have this kind of unwanted generation. So instead of thinking about it as there's a memory in there, instead it's maybe something closer to a prompt that you don't want, right? Okay, there, I just came up with one. Here's my new theory of PTSD. That it's not about the memory sort of being intrusive, but rather it's about pathological prompting. Because the memory can be generated, but you can generate all kinds of other stuff too, theoretically. There's a reason, for some reason, in people who have this condition, that they end up prompting their minds to generate this particular sequence. And so thinking about it in terms of that prompt engineering, almost, self-prompt engineering, as opposed to something like, the conventional perspective, from what I know, again, the little I know about treatments for PTSD is typically to kind of overwrite the memory. People build a new association, for example, in order, I think what do they call it? Reconsolidation is an important approach for things like PTSD and other kinds of intrusive kind of memories where you're trying to override that memory with more positive experiences. And correct me if I'm wrong about this, but if you think about it more in terms of, no, what you have is the potentiation. It's not that there's a memory there. Rather, you have the potentiation to produce this memory given the right prompt or the wrong prompt. Then you have to think more in terms of what would it mean to guide yourself away from that rather than trying to get rid of the memory or override it.
I have several things I want to say to that, but I think first we should go to Dugan, who has his hand raised.
Right. Thank you. So for PTSD, it seems like it's not a forgetting, like in Alzheimer's, that there's a memory deficit. For PTSD, it seems like there's a very burned in memory that's high stress, and remembering that is just all kinds of bad, stressful for the person. So there's a defense mechanism to try to block that out. But there are like things next to this memory that are associated to that memory, other memories, basically. So if you get one of those in your attention, then it's going to go to that stressful, PTSD memory. So it's like it gets prompted. And I guess the strategy you mentioned for treating this is to unassociate those nearby memories so that they don't go to that one. So it's like you try to disconnect it from your associations.
Yeah, exactly. So, again, this reformulation would say it's not that it's a burnt in memory, like that it's, anything like flashbulb memories. The way I would think of it is that all memories are just kind of potentially equally likely to be activated if you get into that autoregressive sort of thought stream. And so the target would be potentially different, would be don't activate it. Now, in effect, the therapeutic intervention may be the same, because you're talking, right? It's not calling it a prompt for an autoaggressive process versus just a retrieval cue for the memory may just be incidental in the end. It may not matter how it actually plays out. But I guess I'm hopeful that if in fact this different framework is correct, then maybe that could have some insights that could further that along. And again, I don't want to do this. I don't want to just shoot from the hip here in terms of like suggesting like therapeutic techniques. That would be very hubristic. I'm not. But I guess it is a good launch pad for thinking of these things. So is it a memory, and the memory is just so powerful that it intrudes on your thoughts, or is it that there's a certain kind of sequence or a certain kind of prompt almost that that lends itself, right? That's what's recurring, right? If for some reason you keep prompting yourself to remember this rather than thinking of the memory as being sort of the thing that's almost like what's active here, what computationally speaking, like what's the problem? Is it the memory, or is it the prompt? And so I would say it's never the memory, because the memory isn't really there. There's not like, this isn't playing in your mind and then it shows up, because nothing plays in your mind until you run the autoregressive process. It's not really there at all. And instead, what we'd say in PTSD is that there's a tendency, a pathological tendency in this case, to kick off a certain kind of sequence of autoregressive processing that ends up regenerating the memory. So again, I don't know how helpful that is in recommending any specific therapeutic techniques, but I think it is a different way of thinking about it, and so maybe it could have some down the road. I would hope it might provide some insight for therapy.
I have 3 questions that I think you'll have very quick answers to, but I'm trying to pin down more precisely what you're talking about.
Me too.
The first question is this intending to be more of a psychological theory of the brain, and that it says, all right, there's all these neurons, but we're more worried about what's happening at kind of the software level? Or is this purporting to be a neuroscientific theory of the brain, where you're actually saying something about, all right, here's neurons, and here's calcium waves, and here's microglia, and here's how they're storing memory and retrieving memory?
That is a spectacular question. And I would say right now at this level, I'd call it psychological / computational, in the sense that just at a high level trying to characterize what the brain is doing at a sort of sort of a functional level. One of the reasons I'm very excited about large language models and autoregressive theory is not only because I think it might be sort of the right characterization, but because I think it really drives home this idea of thinking about, well, what's the brain doing? Well, we could say we've now got it running in a completely different substrate. Let's just say this is sort of accurate. Then we've got it running a completely different substrate with completely different, it's not being done. I'm not claiming the brain's doing transformer models or anything like that, but we could say that what you're doing is just predicting the next token. Now, how you do it in the brain specifically, I could say I'm agnostic to right now. So first of all, just that level, right? Just a computational / psychological level, if you want to call it that. But of course, the hope is that this would provide a new framework for thinking about what the hippocampus really does. For example, what is long-term consolidation? Is it storing of sort of static memories, or is it fine-tuning a model, a generative model? Right. And if you say it's fine-tuning a generative model, which is what I would claim, then does that characterization potentially give you different avenues for thinking about what the hippocampal structure is really doing in sort of memory consolidation? And so I would say it's aspirationally very much the second, but right now it's only the first.
All right. You use the term framework in there, and that's a great segue into my next question. There's constructivist theories in science where you're trying to build a useful framework for understanding something without necessarily build a framework that lets you have more useful thoughts about a thing, but your focus isn't as much on making empirical, predictable hypotheses. So like the biopsychosocial framework in therapy is an example of this. It doesn't make a lot of hypotheses, but it's a useful framework for understanding what's going on in a person's head and pathologies of disease and things like that. And then there's objectivist theories where it's very much, all right, general relativity. My theory predicts that this is going to be this number and this is going to happen and not this. Would you consider your theory more of a constructivist or objectivist theory?
So just to understand, so one is kind of more in terms of what is, and the other is like just prediction. Is that sort of a breakdown, like what's actually sort of ontologically true versus like what we can say will happen? Or if not, then
I think less about ontology with constructivist theories and more about providing a high-level understanding that lets you form sort of more useful lower-level understanding of a thing. So like the free energy principle, which Michael Levin talks about, this is largely a constructivist theory, and it's a really powerful constructivist theory because it's allowed people to form sort of smaller theories within that umbrella that make really good predictions. But the free energy principle itself doesn't make a whole lot of very precise falsifiable predictions. Does that kind of make sense?
I see. Okay, I think so. So I guess, so you're asking to what extent does this theoretical framework make granular predictions, is maybe one way to think about it. So I would say at this point, and maybe you're even pushing back even harder and saying, is this falsifiable, or is this just going to be a way of accounting for everything else that we already know? Will it make novel predictions? And so I'm working on that. It's a very valid question. And my hope is that as I continue and perhaps, others maybe take up some of the work to explore this theory, that there are going to be clear divergent points where my theory will make very specific kinds of predictions. So, just to share some possible range of predictions, it would be, so short-term memory is really meant to be 15 to 30 seconds. And it's meant to be this separate, distinct memory store. And the idea is that once the 30 seconds have gone, there isn't any trace left of that information that was formerly in short-term memory. The only way that information can continue to exist is if it goes into long-term memory. My theory is that there's no discontinuity at all, right? There's no room in my theory there's no short-term memory and long-term memory at all. There's just a fine-tuned model, and then there's the tuned model, and then there's generation, and then there's residual activation that forms the context. And there's some decay function or something, some decay of influence as you go further back. But what I'm proposing is that once we have this perspective and look at guidance rather than retrieval, but we look at guidance, like how much does what I'm saying now, how much is it guided by what I said 30 seconds ago versus 5 minutes ago versus 10 minutes ago, that we're going to end up with really actually powerful predictions about the guidance that are just not accounted for at all in the classic short-term and the long-term memory division, that you're going to see a sort of continuous function. And so I think you're going to have powerful predictions about what kinds of behavioral outputs you can get that's going to follow from my math. My math being particularly the great degradation of guidance, of influence on guidance, is going to lead to very different predictions, because the current models really don't even have room for that intermediate. You got sort of short-term and then long-term and nothing in between. I've got everything in between, and I think that in between, in my case, is going to make predictions that the current models aren't going to be able to. They don't have it. They won't be able to account for that level of granularity. So I think there's going to be, I'm hoping that there's going to be sort of much more granular kind of predictions that are going to be predicted here by this model, and it's not just an inspiration, a thought inspiration about how the mind works, but it's really truly going to be a computational model. So is that an answer to which kind of model I'm proposing it would be?
Yes, it does. And thinking about it, I think my third question is going to require a longer answer, so I'm going to pass the floor to somebody else, and maybe I'll come back with that one.
Yeah, definitely come back to it. I mean, I was actually not going to necessarily bring up a question, although maybe sort of. So how many of you have heard of a hallucinogen persisting perception disorder, also known as HPPD? And this is a very interesting thing that it happens in the visual system, but it can happen with other things, and it's kind of self-explanatory. The hallucinations kind of they persist, they stay, they remain, and into your sober state, and it can cause things ranging from a distraction, an irritating distraction, to just full-on perceptual chaos. There's some people that are almost in a never-ending trip. And I'm wondering, just sort of on the fly, if you can find a way to interpret this under autoregression, because this is sort of, theoretically a very interesting thing, but also practically, because people, DVZ, you may have heard of this actually.
I am so sorry. I just had a canvasser knock on my door, and they were knocking really aggressively, so I thought it was important. What have I heard of?
HPPD, hallucinogen persisting perception disorder.
Yes, I have heard of this. It's very serious.
Yes, and I was telling Alon if there's any, interpretation under the autoregression model that would give some interesting insights into this. Because for me, when I've looked at this, especially with how I am with dreams and sleeping and all that, is like I tend to be able to control the perceptual distortions and hallucinations, whatever you'd want to call them, But there are certain cases where I even noticed the first time that I tried something that there was this sort of very subtle thing that remained there, and I had to really put in a bit of effort, even though it was subtle, to make it go away.
Like what? What could you?
So whenever I would look
Don't mind?
at like grids or like very complex, like a like a quilted t-shirt or something like that, like with a lot of those intricate patterns, like there would be this very distinct after image that would stay from it. That would be different from the normal after images that I would, actively try to create. And I had to sort of figure out how to like negate that and remove that. It was a little tricky at first, and
How did you
eventually I
do
got
it?
the hang of it.
How did you read?
Well, what basically what you do is you have to become really aware of it, and then you have to just feel how to. I don't even know how to explain this, but you have to feel like you're removing it, and you have to kind of. Oh man, this is tough. Like you have to try to consciously ignore the fact that you're seeing that after image, and forget it. I don't even know how to explain this in common language. It's something. It's like we were saying earlier. There are those things you have to kind of experience that are. It's much harder to kind of convey the point.
I know. I got you. No,
But it's kind of like Okay, I can think of something. It felt a lot like when you're looking at an ambiguous image and it looks like it could be a lot of different things. You're kind of trying to focus on a way of looking at it. So you're looking at the current after image as a kind of distraction and trying to let the physical image or whatever in front of you push more through and interfere less. Hopefully that's making a little more sense.
Yeah. I mean, I intuitively, I get what you're saying.
Yeah.
Okay, interesting. Is this almost always or always the end result, a sort of side effect of hallucinogenics? Is that where it always comes from, or can it just happen sort of organically?
Well, I think commonly it's understood to come from hallucinogens and specific ones, but I have heard of this happening to people after very intensive meditative experiences. Which, by the way, meditation, as much as I love it and all the things you can do with it, I would not say it is the safest cognitive activity, especially if you're not in a stable place. I think it can actually be quite dangerous. But yeah. But I've heard it happen from that. I've actually even felt some of those lasting effects happen to me after very intensive meditation experiences, where there were these sort of lingering noises and visuals that lasted for a while. Like they lasted for a couple of weeks actually, and they didn't really get in the way, but they were not there before. And I was like, I kind of, whether or not I want them there, I at least like to be able to have control over whether I have them there or not, which eventually of course I was be able to kind of figure out. But no, it can happen from any of those things. It can happen. I think this is also something that happens with PTSD, is where people will because of that kind of overfitting lens or whatever, is it starts to technically pick up. I think hallucinations in a lot of ways could be overfitting. That's kind of the way I'm looking.
What do you call it? Why overfitting?
Because you're really trying to see something that's there, even if it's technically not there. Like when I talk about the lens. Okay, hold on.
I see.
By the way, there are decent explanations of HPPD, and they aren't necessarily overfitting. They're actually that your vision has these things that it's filtering out constantly, and the same with all your other senses. And when you take certain hallucinogens or when you meditate for a very long amount of time, you put yourself into a state where you're no longer filtering these out for a little bit. So like a common symptom of HPPD is floaters. And those are just like the floaters that you'll see in your eye sometimes when you turn your head too quick, but your vision's no longer filtering them out.
They're always there.
They're always there. Seeing trails, like light trails almost behind things, is a common symptom of HPPD, but that's actually something you see anytime there's a lit up thing in a dark environment. Your vision just filters it out. So yours is a little bit more phenomenological, Addy. And so that one might not be an example, but most of the examples of HPPD symptoms can be explained, even like the auditory symptoms can be explained by things that your brain no longer filtering out things that your senses usually filter out for you.
Well, actually, one thing I do want to add to that then is, I talk about this. Have you heard of Kasina meditation, fire Kasina meditation? Okay, so it's this thing where people will kind of stare at a high contrast object, like maybe a kind of a flame or a screen or something, whatever, and they'll really focus on that after image. And, you know, people can do this for hours and hours and hours, for days and days and days, and for ages. And what'll start to happen, especially, you know, to some people it'll happen more quickly, is that, you know, if you move your finger across your eyes, it actually, even just looking at your finger, has this trail, right? And it's, you know, you don't really notice it except for in certain settings, that there's that kind of motion blur, that trail. But even something that's not necessarily lit up,
All that
like,
sensory memory, but whatever. Go on.
well, no, I mean, that's actually what I want to bring up about how this Casina thing, sensory, memory, HPPD, and autoregression are all kind of related. Like, how would you look at that under the autoregression mode? Because again, I sort of have my own perspective of tying these things in together, but I want to know if this is connecting.
Very, very interesting. I can't speculate too hard because I haven't had really, you're introducing these to me, but in the case of PTSD and this kind of, the thing that rings a bell, and this reason you're bringing it up, I think, is because it seems pretty clear in these cases. You know, Daniel's talking about, you know, there's certain kind of sensory information that impinges on us all the time, and there's a sensory perceptual process of filtering and processing. Some of it gets filtered, some of it's, you know, ignored past a certain level of computation. Some of it ends up getting computed, and that all happens kind of, I don't want to say passively. It's interactively between your perceptual system and the actual world, with stimuli that are impinging on it. But when you're talking about hallucinations, you're talking about PTSD, these are self-generated. This is where the mind is going off into and generating, sort of self-generating the pattern. So to me, it certainly rhymes strongly, and it reminds me very strongly of the kind of generative processes that I'm talking about in relation to thinking and talking, and imagining and visualizing, which are self-driven, and therefore I think are a ripe candidate for being autoregressive in this way. So how does the generation actually work? What you don't have is, right, you know, when you have a vivid hallucination, or something like that, how does that really work, right? Now, we could think of it as, you know, the hallucination is just happening to us, but that's not true, right? Of course, the hallucination is not happening. It's your mind entirely creating the stimulus that you then experience. And my guess would be, and of course, you know, if you have a hammer and nail, you know, everything's a nail, but my guess would be, and I'll talk about dreams in a second, but my guess would be is that the hallucination depends on something like autoregression. In order to get to the next step in your hallucination, you have to kind of have encoded the previous one, feed it through, and you're running this as a sequence. And so there's a self-generative process that depends on this kind of residual activation, and then feed it through. And so if in fact that's the case, if all sort of self-generated time dependent processes are autoregressive, which is sort of, that's another way of encapsulating my perspective, then you could have different targets of thinking about how you could disrupt it. Because it's not only about, you know, once it's going, what are you going to do? It's that in order to continue appropriately, you have to keep the autoregressive loop going. So it certainly opens up the possibility of thinking about these kinds of time sort of longer duration, distressing, self-generated processes, and yeah, this is great. I mean, it's great that you're sort of naming. I hadn't thought of either of these, but PTSD being a great one. I forget the name of this disorder you're just referring to, being another one where there's an auto-generative component to it, where your mind is making stuff up. It's probably happening autoaggressively. I wanted to mention dreams real quick. So I've talked about this a lot with Will Hahn, that dreams seem to be just autoregressive generation with a really short context. So if you remember the early days of deepfake videos, and you can still find some of these on the internet. They're really fun. Actually, anybody watch the show Severance? So if you watch the opening sequence, some of it has this feeling to it. Things start to just go off in these wild directions. Suddenly he'll split off and to become something else or something like that. And a lot of the early, like I said, early video generators did this. And one way to think about it is what they're doing is they're maintaining consistency. Over a few frames, you're always going to have consistency. Like you're in a dream and you're sitting at your desk, and then you look out the window and suddenly you're flying in a spaceship instead of just at your desk. But if you look at the last 3 or 4 frames, and you can't really do this in the dream, but the idea would be that what your brain is doing is it's autoregressively generating. It's generating from the most recent frames, and it's producing something that makes sense. But it doesn't make sense in the longer term because I was just sitting at my desk a few seconds ago. How the heck am I in a spaceship flying around? But from the dream's perspective, from the way the brain is operating, it's only taking into account sort of the very recent, super recent past. And so what you can see in the case of dreams is you probably catching that sort of a failure, if you want to call it that, of the autoregressive system to appropriately take the past into account in the next generation. In the case of the disorders, that's not the case. In PTSD, once you're in it, you're stuck there and you're going to relive the whole thing. But imagine if we could disrupt the process so that you no longer have the most, sort of that last 30 seconds, then you're not going to necessarily generate the next thing. Just because it's on play right now doesn't mean it's on play. There is nothing playing that. Your mind is generating it. It's making it up based on what just happened. And so theoretically, if you could disrupt sort of that process, give people in the middle of a PTSD episode, and I'm not recommending, nobody should do this because I don't know what I'm talking about, and I don't want people, introducing clinical practices yet, maybe this week. But if in the middle of the PTSD, you like at a certain point, you just something very distracting, could that break the spell? And then if you do that repeatedly, would the continuity end up getting disrupted enough that maybe the autoregressive process would start getting disrupted? I have no idea. But yes, I really think, I would say strongly that if you're talking about self-generated, mind-generated processes where it's not based on impinging input, not the kind of thing Daniel's talking about where you can't filter out stuff properly that's actually coming in, but rather where you're making it up, your mind's making it up, that's probably a really good candidate for being an autoregressive process, in which case maybe different kinds of therapeutic techniques could work.
Yeah, and like, I mean, when I was talking about the fitting stuff or whatever for hallucinations, is like, how, if you maybe some people have an easier job doing this than maybe the others, but let's just say you're looking at your carpet or your t-shirt or the clouds or the trees or whatever, and you can sort of see things that are not technically there.
Yeah.
Right. That's that lens thing. And I think part of what the lens is doing is it's trying to fit it in accordance to something. Right. Like technically, yeah, that face is not there in the clouds or the trees, but you're kind of fitting that onto there. You're projecting that onto there. At least that was the way I was thinking of the overfitting thing. And, some of the visuals you'll have in a dream state, or especially, if you're under some hallucinogen or whatever, is, yeah, like people will often describe when you go on those substances, like, this computer in front of me looks like a face. Like you're starting to picture that out. Like you can actually see the face in it, but your brain is sort of is selecting certain details that creates that representation, putting more focus or weight on them or whatever. And you can try this just by looking at like the texture on your clothes or your carpet or your flooring or the trees or the clouds or whatever, and you can practice this. I mean, another thing you can do right now is go pull up a video of like noise, like, like the white noise, whatever, or visual noise, whatever, on Google Images or YouTube or whatever. And, you'll notice that your brain will start to make these shapes out of things. And you can keep doing this more and more and more and more. And if you get really good at it, you can basically get entire detailed faces and stuff out of that. It's not actually that hard of a thing to do. I mean, you could, if you really tried, you could probably knock it out in a day or two, honestly.
I mean, I've had the experience, certainly. And so I'll sometimes see something that could just be something, concrete or something like that.
Right.
And then I'll suddenly spot, like, oh my God, I could draw a perfect face. And I'm not very good at drawing faces from scratch, but I can copy something very, very well. I've always been good at that.
Right.
And I'm like, oh, I could copy this right now, even though it's not there. And I've done it actually. I've drawn the face that's not really there because there's enough there that's just lends itself in that direction that it can push you towards, seeing, as you say, sort of seeing something that's not there, or that is there, I guess, and so where there's sufficient information there that you're able to sort of fill in the rest. I don't know to what extent my theory has that much to say about that, because my theory, so one big kind of deciding factor for me, like, if you imagine the sort of the kind of decision flow chart, one way I think about this is if it takes time, then it's probably autoregressive. If the thought process takes time, if you have to sit and deliberate, if you have to, in order to imagine it or to think it through, inner monologue, then your brain is doing the work independently, and it's sequential, and it's probably autoregressive. If you're talking about seeing something in the present, I would say that's probably not autoregressive. At least I wouldn't want to claim that it is, because it doesn't have this sequentiality aspect that autoregression inherently does, right? Autoregression is literally the reason why. So in my theory, like thinking fast and slow, the reason why certain things take time to think about is because you simply can't just do input output. You have to run the autoregressive model, and it has to be run over time, because you don't have the answer right away. Like the same way that the language models can't take in, we'll get it, diffusion models aside for now. You can't take in a long sequence and then spontaneously output the whole paragraph. It has to do it token by token. That's why I think certain type of thinking takes time. But you're talking about something where you're kind of filling in information on the current percept, and maybe you're doing that sort of sequentially, but I don't know. I'm not sure if it would fit my model, but I think it's a great example of the sort of type 1 thinking, which is just single loop. Like, here's the input, and I'm going to impose my drawing on it, and it happens probably in parallel. It doesn't require the kind of sequential reasoning that autoregression does. But it's a fascinating point. It's a fascinating topic.
I'm wondering if Jesse or Dugan, if they have any questions or ideas.
Maybe they're convinced.
Maybe not. Dan, do you want to finish up your point?
I really can't debate it. It's just so clearly true, everything I'm saying. So,
give me just.
Oh wait, Dugan.
Dugan doesn't like that, right?
Yeah. So I don't think that our speech is autoregressive. I don't think we talk in an autoregressive way. I think it's more web-based and more associative. And when we think about a thought, we think like in chunked data. We're talking about, let's say, a guy wearing a blue shirt going out to the beach and looking at the moon. We have those thoughts first in a web, and then to spit it out using our mouths, we have to sequentialize it. And so, we get a sequence going.
You think it's just how we have to, it's just how we have to produce speech. That's the medium, and
right.
The fact that it's sequential and all that is just like an artifact of how we have to produce the sound.
We have to serialize it to each other, communicate. If we can communicate in web-based medium, if we could just like show a picture, just flash a picture of our thought, it might be a web-based thing.
Well, what about language itself? Forget about, yes, let's say you could flash a picture, but given language as a medium. So what you're saying, what you're saying is that language is just a serialization of the thought is really just instantaneous, and then when we produce the language to communicate the thought, but the thought is not inherently autoregressive, including the serialization is literally just an artifact of how we have to get it out of our mouths, but not really how we have to get it out of our minds. Is kind of the perspective. Right. You are the enemy. You're exactly, and it's very well articulated. It's exactly the point that the burden is on me, and this is kind of what I'm working on all day, is to try to make the case that language is first of all, language is autoregressive, and then I have the stronger, bolder, crazier claim that generally thinking is autoregressive in this form. There's certainly certain thoughts that could be very rapid, but the thinking through something. But yes, I agree. I'm not in a position to debate that exactly. I could sort of, we could go offline and I could sort of tell you why I think this is the case. The strongest reason I have, frankly, is because the LLMs are so freaking good, and because they are built on this particular mathematical framework, and they operate inherently autoregressively, and language, lo and behold, is also produced this way. No, it's a chicken and egg. It's the way they're trained is on sequential language. And so maybe that's just ends up being an artifact of like how you can get them to do this is autoregressive. I think there's reasons, some of the things having to do with the structure of language itself and the performance so far of large language models that leads me to propose this. Now, there are other models. Daniel has been talking with me about diffusion models, which don't operate autoregressively. They seem to be potentially catching up, which could potentially, pose some counter evidence to this idea that language itself is inherently autoregressive. I still think the argument would still go that maybe our speech is autoregressive, but it would be less convincing under those circumstances. So I hear you.
So
I hear you.
The diffusion model is like a different way to, so it like fills in some random text and like percolates it until it's more distilled, and like attention heads go over the whole thing.
Level, it does it, from what I understand, it does it at the sort of in the like layers, the earlier layers. It's not happening sort of at the very last actual where it's producing the distribution of the actual final outputs, but it's doing it somewhere deeper in the system. But I'm not well versed in it yet enough. It's useful to ignore it for now for my theory. So I haven't spent a lot of time looking at it, but something like that. But the noise is not happening at the token level, like in the outputs. That's not where the diffusion process is happening. That's the only thing I can say about it. But what it's doing is it is potentially generating sort of more holistically and more globally. But here's the but. I think it could still be doing autoregression probably, because in the distillation, as it's doing the diffusion, it really is making decisions about which word should go where, and it could be doing that. This would require looking more closely at the process, trying to maybe manipulate the process. It could still actually be doing it autoregressively. It could be like an implicit autoregression from my reading, but don't trust me on this. I'm not an expert in those models yet. I'm working.
What I would hope, or what I would want to see, is sort of a top-down data chunks sort of thing, where you give it a prompt and it'll map out a few big thoughts and then connect them and then drill down into the words and the tokens. Make an outline first before you write the paper, kind of thing.
Cool. So I think that's probably it's not exactly a counter argument, but it's a hybrid version of the way I think also that it probably works to some extent. So although I can sound dogmatic about this, when we're I had this experience. I just did this with the LLMs, and I said, tell me a story in a paragraph, because I wanted to do that thing I mentioned earlier, where I wanted it to then ask it to repeat it. And so it gave me a story. It was a pretty cool story about a watch, and you turn the watch backwards and time goes backwards, all in a paragraph. Very nice. And I got to wondering, and it is truly puzzling. You're like, when it said that first word, all I said is tell me a story in a paragraph. When it said the first word, it had no idea where it was going. It can't possibly. It didn't have a vision of a watch. It certainly didn't have a watch that would go backwards. We know enough about these models to say that when it got to the fifth word and introduced a watch, it didn't know where the story was going to go. And so it wasn't doing this holistically, and somehow magically, and which is where I find it astonishing, it was able to come up with what looks like a well thought out, well crafted story from beginning to end. How that works to me is astonishing. It is, but we know that it's not doing anything holistic because they are autoregressive. Unless somebody's lying to us about how these models actually work, they're not doing that. However, I don't think humans do that. I think if you ask me to tell a story, I'm going to get sort of a quick flash, maybe some visuals, where I could, sort of see the storyboarding happening in my head, and that might not be autoregressive at all. That could just be like I have sort of like a comic book version or something like that, that's sort of much more holistic, and then I have to describe it linguistically. The linguistic piece, I would still say, is happening autoregressively. Just like you can give a model a picture and say, describe this picture. The picture is being encoded holistically. It's not being encoded autoregressively, but the formulation of how to describe that is autoregressive. So I completely agree with you, and maybe this is closer to your view. Maybe we could even agree or something, that thought itself certainly happens in not strictly autoregressively, that we get sort of flashes of inspiration, intuition, things like that that can come in sort of in a single frame, almost like instantaneously. And like a lot of theories, you kind of have an intuition. It's like, boom, I know what it is. Now I have to lay out the theory, right? Like my whole autoregressive theory, I probably got it in sort of in a single, like, oh wait, crap, this is what the brain is doing right now. What does that mean, and how do I articulate that? That I think when you have to lay out the details linguistically, I think you probably do that autoregressively. I think it may apply to other stuff. If you have to think through a visual puzzle, maybe do that autoregressively. But yes, I don't want to claim that everything that's happening in our brain is just this kind of sequential kind of process. There are other kinds of things happening that are more parallel, more holistic, and things like that.
I feel,
Go ahead.
since we're talking about diffusion models and stuff, I feel like I should clarify the reason why I bring that up as an important thing is because autoregression and diffusion models rely on transformers, and in general, these things are arbitrary function approximators. So if you throw enough data at them and give them enough parameters and enough compute, they'll learn to do almost anything. And the fact that they learn to do a thing doesn't necessarily mean that the thing they learn to do looks anything like the actual architecture of sort of the transformer. But one thing that Alon's been pointing to is that the fact that autoregression seems to do language so well could point to the fact that this is a good natural fit for the architecture of language itself. And the reason I'm pointing out diffusion is the fact that diffusion, at least at smaller scales, it hasn't been scaled yet, at least at smaller scales, seems to do as well as autoregression. Indicates that maybe there's this more general function and these arbitrary function approximators are just approximating to it. Which would be somewhat disappointing for me because I would love to solve this in a bigger way, but I think it's worth pointing out specifically why I've been talking about diffusion so much.
Right, and it is right. In other words, if you just, there's these different models, there's different ways of building the different. I guess one way to think about it is, and people have made this point. I don't remember the exact terminology. Is that maybe architecture doesn't matter that much, and you can get they're all different ways of getting arbitrary functions. They're all arbitrary function approximators, and it doesn't matter how many layers or how exactly what you have skip connections or anything like that. There's nothing profound about the particular architecture, and that could be the case in that there isn't really a whole lot of insight, certainly from the specific architecture, like transformer. Again, I'm not tied to transformer models. The autoregressive piece for me, the reason why I think it's so interesting, and again, it may be wrong, but it's not about architecture. It's about process. It's not about how you get to the function. It's what is the nature of the function itself. Because autoregression is not, it's not a function. It's that you have to take the output of the function and then feed it in again. It's a dynamical system. And so claiming that it's a certain kind of dynamical system rather than just a function approximator is a different kind of claim. Now, whether it's the right one, whether it has to be that kind of dynamical system, of course, needs to be demonstrated. But it is a different kind of claim than saying anything about the specific neural network architecture, or however you build your function approximator.
So the neural nets are like function approximators. I think that the attention agent is more of an associative mapping. That it's this big matrix, and the matrix has row and column associations of token to token. So it's like, the man and shirt, and the shirt is associated to blue, and the whole thing is associated to going to the beach and looking at the moon, right? So all that association creates this like high concept story, and then parsing that into words is like the next step that the autoregression algorithm does. I think that autoregression has, because of the transformers there, is developing a higher level web of thoughts behind the scenes that's hidden from the tokens that are being output.
So that I think it's a natural conception to have, but I want to push back on it a little bit because they really are just doing next token. So they are really just a single pass. It is just matrix multiply ultimately, and all of those webs of relations are certainly capturing something that we could call vaguely semantic, like this word is related to that word at a certain level, but still the fact is it's just a single forward pass network that doesn't have within it the longer form semantic facts, because all they're doing is the next token. Like
well, as it feeds through the prompt and up to the current token, it's taking, like, the attention is getting baked in an associative matrix through that process.
But it's really just determining how much each token is influencing sort of the final output, but and how much it relates to every other token. But there isn't, like, I guess what I'm saying is there's no, we can't think of it as like, as you go through layers, it's certainly getting richer and richer representations of how different, and not just richer, but also different. Well, you have the different attention heads, and they're sort of characterizing different kinds of relations between words, how these words relate to each other. Maybe it's this kind of syntactic relation, and the other one is doing some other syntactic relation or something like that, or semantic relation, however you want to think about it. But as you flow through the network, it's not like it's thinking through in any sort of sequential way what's going on. It's just building up those richer kinds of relation maps between the tokens. So there isn't, it's tempting, and I kind of used to think of it this way. It's tempting to think that as you're going from input out to the output, it's sort of thinking through, sort of sequentially across the layers. But that's really not what they're doing. The layers are just getting more and more abstract kind of maps of the associations, such that you can make that next token generation. And so semanticizing what that process is a little hard to do, but it's definitely not like sort of sequential thinking or anything like that. And so, like, the idea, like an orange is has a citrusy flavor and stuff like that, it's not happening. Like, that's not as it flows through from input to output. That thought's certainly not happening, and so it's never really happening in the model. The model only lives. It's a weird thought, but if you're like people talk about consciousnesses of these models, the model only ever experiences the single pass, like input output. It doesn't get the sequence, and so it never learns about how the world operates over time, or that any sort of complex ideas. It only knows how to guess the next word from the previous ones. And so thinking about what the semantics are in that relation is, I'm not saying they're not there, that there is some sort of semantics there in this web of associations, as you're putting it, and it behooves us to think about what that semantics is. But it's very different from the kind of semantics that I think we think of, like knowing things about the world and how they relate to each other that we can articulate in more than one word. It's not really in there.
I mean, LLMs know that the sky is blue, not because they've seen it, but because it's been written about.
I'm sorry, they have the skies?
Blind people know that the sky is blue.
Right.
But not because they've seen it, it's because they've heard other people talk about it.
Exactly, and that's the LLMs. The LLMs don't know what sky and blue are, and they in fact, as I said in a presentation I just gave, is to them it's just arbitrary squiggles, and they're savants at figuring out the relations between arbitrary squiggles and how they predict other squiggles. There is no sky or blue or any of that.
Right, so they know that they're related. The squiggles,
that's right,
tokens are related.
Yes, in a highly structured way. They know that better than we do in some sense. They're really good at this, sort of being able to know how they're related, such that they can then produce. Although I'm arguing that it's the same thing we're doing. That we also are just squiggle predictors, and that's a useful tool. It happens to be embedded in a larger system, a cognitive system, where we also know what blue and sky are, although I don't really think
Right.
words.
We have words for the sensory sensations, and then we have an association built up because it's being associated by an external reality.
That's right. Or an internal reality in any case. But yes,
Sure.
right. But we don't need to get into that.
We have thoughts and we have sensations, and that's what's making our language associative.
Yes. Now, I don't know if this is the place for it. I don't. It's a longer conversation. I don't think our words mean in the way that we do. I don't think the word blue is associated with all kinds of stuff, including not blue, and it really is just the linguistic system, and it is actually a sensory, but it's ensconced in the sensory system, and it cooperates with the sensory system such that it feels like to us as the holistic, unified creatures that we are, that when I say there's a beautiful blue sky out there, like I'm seeing the blue sky, I'm uttering these words, and it feels like I'm really actually representing that fact with these words, but it's much looser than that. It's really just it's for purpose of coordination, and I don't even call it necessarily communication, but longer story. But certainly we do experience that kind of association. I use the word blue in a way that's typically associated with when I have certain kinds of sensory perceptions. But of course, philosophers tried forever to really say, how does blue mean that thing? And how does cup mean that thing? And my answer is it doesn't. Cup is just a squiggle that does certain kinds of work.
I thought you said cuck for a moment.
I thought I said what?
I thought you said cuck for a moment.
That I don't know what that represents, but I guess my argument would be similar to cup. So it's neither of those are really representational, and so it's a useful system for coordinating behavior, the language stuff, and it tends to coincide with the sensory stuff in a predictable way, or meaningful way, but it doesn't really mean in the way that we like to think. So this is sort of a broader critique of what language is.
You're talking about the words. The words.
Yes, I'm talking about the words themselves.
Intrinsic meaning? No, they don't.
They don't have any meaning. They're much closer to the squiggles in the LLM, but they're very usefully embedded in a larger cognitive system that they play this role. It's kind of like multimodal LLMs, where they're still just doing language games, but they're doing it in a way where the visual image is kind of tokenized in such a way that it's predictive. It helps guide the language generation. But the language model still doesn't know that blue means the blue in the image. It does not. It's not really representative in that way. I think it's the same for people. That's sort of my.
Yeah, I mean, even what gives word meaning, if you just start a new language and you say, okay, a rock means, and you point to a rock, right? You say, okay, I'm associating this phoneme with this class of object.
Yep.
We all agree on that, and we move on to the next word.
Yeah, but that's
so it's associative in that you have words being bound to, in this case, like sensory perception or some sort of external type of thing.
Yes. However, like Quine pointed out, it doesn't really work well, because what's a rock? And do we mean from this angle and under the right lighting? And what if it's smaller? What if it's bigger? And the point is, no, this thing works very well to communicate something that ends up being useful and that we all agree is a rock, but there really isn't a platonic rock that this word means.
No, there's not. But once we decide on that, hard means a type of material property, and then we have the word rock being associated with the word hard, because there's this external reality of physical rocks in our environment that exhibit both. And so we could have an LLM know that rock is associated to hardness, even though it's not going through the intermediary external representation of what those objects are actually in reality.
Right. Yeah. There's many lifetimes of sort of kind of thinking through how does this You know, one thing I certainly don't have a good account of is, but don't blame me. Like neither is humanity, and has been working on it for thousands of years. Exactly how the handshake happens between the squiggle system and the external world as transduced by our sensory perceptual system. Like somehow this ends up being a useful communication system that we can coordinate visually, right, based on my words, and not just behaviorally we can coordinate, and it's, but that may be, although that's definitively true, I think that can lead to certain kind of naive assumptions, and I think historically has led to naive assumptions about words carrying meaning external to them, to just their internal their internal statistical structure. And so that's one of the things I love. The reason I'm so excited about this is because even though there's still a lot of hard work to do, I think it brushes away, or at least cuts it responds to all of these kind of philosophical, vague kind of intuitions and says, well, they're not right. The words don't have the meaning in the way. It's just like this. Now, how does that actually lead to coordinated good behavior? We're building systems that are going to do it. I mean, it's happening right now, but there isn't some magic semantics like in intentionality and all this stuff that philosophers have been fussing over for all these years. No, we have sort of it's autogen. Well, I think it's autogenerative system where there's inherent kind of there's structure to the language itself, where language begets language, and that also can be tokenized, prompted by the sensory domain, so that you end up with language. Sort of like if you tell an LM, there's an object on the desk, you're standing 3 feet away from it. And what should you do? And if you want to pick it up, you have to walk it will do just fine, right? It has to say, I'll walk over to the table and I'll pick it up. That's sort of what language is doing. It's helping, it's coordinating. I think of an operating system more than like a communication system. And that's starting to get very concrete. How does it do it? Well, it's a damn good system. I don't know how the hell it does it. Whoever made this thing, and don't ask me for my theories on that because I think it's too damn good, but it's very well engineered, but what is it doing? I think it's doing just this coordination. It's not meaning in some language, isn't meaning in some kind of mysterious way. It's just leading to coordinated behavior and things like that. That I think you kind of agree with that more than the autoregressive piece.
Yeah, that resonates.
Cool. Yeah, you should have been to the talk I gave at Mindfest. I'll get you a copy. That was the key point there. It wasn't really about the autoregression. The autoregression was just to say, like, look, this is all these things are doing, and oh my God, they're so competent. Looks like language just run based on its statistics. You don't need reference. You don't need external. It just does the thing. It does it by itself. And whether it's doing autoregressively or through some other capacity is not really essential.
Right. It's not going through an external thing. It's going through its matrix, which has been baked on people talking about these words based on the external thing. You could replace the external thing with a weight.
Yeah.
Waiting.
Yeah. Now, I mean, but of course, developmentally and all of that, like it mattered that it was the external thing. Like that's how the words are useful.
Functionally, it doesn't. That's the lesson of LLMs. You can get away with faking understanding by using the associations that are developed from a proper understanding.
Yeah, and so the stronger claim though is that we're all faking it. Like our language is just that too. It just feels like we're doing something more.
Well, if we're faking it, we're using a lot more. We can go to the sensory token of rocks being hard to make the words come out. Okay.
That's right. That's a great way to put it. We can sort of create our own environment such that you end up prompting the LLM in a way that ends up mapping to sensory domain. But yeah, I think
you had your hand raised.
Yeah, a couple things. One, what you were just saying, Dugan, is very close to the predictive processing or active inference theory of cognition, where we have ideas about the world, and then we can go because we're embodied, we can go physically test them with our senses. And if our ideas are right, then our sort of internal world model, whatever that looks like, I don't like that term, continues. And if our ideas are wrong, we have a high amount of surprise. So we have a high amount of updating that we need for whatever our internal thing is. One other thing I wanted to mention, by the way, is that you're talking about associations, Dugan. I've been meaning to send this to you as well a lot, so this works. I sent a paper in chat that points to the fact that at least Llama 3 70 billion parameter version might be sort of abstracting to this level of association, doing operations within association space, and then choosing the next token based on that. I don't know if it invalidates auto-regression per se, but it certainly points to something close to what you're talking about, Dugan.
And it's predicting next token by mapping through a more data chunked sort of representation, intermediary representation.
Yes, and I should say this is a brand new paper, and I haven't seen any other paper like this. So it's not like I'm throwing in a well-established area of science that's been around for 10 years here. But I think it's interesting, and I think they did interesting work. Can I have permission to maybe? I raised my hand because y'all were having a fascinating conversation, and the question I had was sort of a different rabbit trail. So I wanted to make sure y'all were good with the conversation you were having, and were good with me.
You only have my permission. Eddie?
I'm good. Dugan, you good? Jesse, you good?
Good.
Cool. So I have one simple question, and then I have my more complex question that I was asking, that I wanted to ask earlier. The simple question is, Alon, at a certain point, it would seem like you sort of implicitly in your theory have something like training an LLM, or you're training whatever the autoregressive function is in some way. And so at some point, something is no longer, so you have sort of two parts. You have the trained function, and then you also have the current buffer. What is at some point, obviously the current buffer becomes something like the trained function, in the sense that if I say something right now, that's probably in the current autoregressive buffer. But if I recall this conversation tomorrow or in a week and generate more tokens of this conversation, maybe when we're grabbing beers later, that would seem to me that that's not in the autoregressive context window. There's just not room for it between this and everything else that's happened in my week. So that would have to be in something like the train function. What is the time scale where something goes from being in the autoregressive context window to being part of sort of the train function?
Great question. No idea. And this is sort of so, I make it sound like it's real nice and neat, that there's sort of the regressive buffer, and that's, there's some sort of residual activation. I don't think that's certainly not 30 seconds. I think it's considerably longer than that, probably. But then there has to be a transition to what I'm calling parameter tuning or weight tuning, which is like, if we're remembering this, you think about this conversation a few days from now, what does it mean to think about it? I would say, yes, it's not in the buffer anymore, probably. I don't know for sure, right? Because how can we, given that I'm now throwing out short-term, the classic short-term memory distinction, I'm saying, well, just because you can't remember the words for past 30 seconds, maybe it's still there in the activation buffer, or sort of in the buffer. Maybe it's still there for 3 days. I have no idea. But more realistically, my guess is that there is the kind of consolidation that happens, and you have synaptic consolidation, and then you have sort of systems consolidation, and that synaptic consolidation is sort of a kind of a fine tuning of the weights that's happening over a fairly short time period, and that when we're rethinking about this conversation later, what you're doing is you're actually accessing the fine-tuned model that's once again reproducing its version of the remembered conversation in sort of an autoregressive way. So what that timeline looks like, and what does that transition look like? What counts as residual activation versus training versus retuning the weights? I'm certainly claiming that those are radically different things. Maybe I'm wrong about that, but I'm claiming that those are very different things because one is is sort of guiding well, one is the buffer, right? Something like a buffer, and the other is the changing of the weights, and they certainly are in the unaggressive space. Those are very different things. So presumably they would depend on very different neurophysiological mechanisms. But I'm so spitballing here that I would not deign to answer that question. I don't have a solid answer to that question, but it's exactly the right question in terms of me having to further elaborate and articulate what the hell I mean by, for example, a buffer in the autoregressive sense. Like where is that? What is that? Now, it's whatever people have historically referred to as short-term memory is going to sort of be that thing. It's sort of the residual activation of what happened in the past is still sort of active and guiding generation. And there's solid neurophysiology behind the idea that there seems to be, you have neurons where if a monkey's trained to remember a location, you'll see like a location-specific neuron that will maintain its activity past the duration of the thing actually being present. Right, here's a little cue. It's supposed to remember that cue. Take away the cue. You still see the neuron firing. And so sometimes people are saying, okay, that's it. That's short-term memory. There it is. I would say, well, that's not holding that piece of information. Rather, that's just guiding activation, which sounds like almost the same thing, but it would have a very different computational meaning than theirs. So that'd be some place to look. That's the actual residual activation, and that does go away, fairly quickly. But the problem with that is, then how do you get this kind of, 5-minute kind of guided activation? Is that, and here's where I really don't know. I don't know the answer to this at all. Is it that there really is just sort of maybe a 30-second kind of buffer, and things are constantly getting updated, like like 2 minutes ago gets dragged in to that 30-second kind of residual activation, and that's how far back it goes, or it really goes back a few minutes? These are completely unspecified.
What's fun is
theory.
I remember you mentioning a trigram at the beginning,
Yes,
talking about trigrams, and you mentioned one, and
you remember it?
G, J, D, or something like
I also
that.
remember a J and a G in there, so that's pretty cool. Okay.
Yeah, that's all I remember. I don't remember the third one.
Now people call that's long-term memory. I'm like, come on.
No.
No.
Integrated. It's short-term memory. I do remember that there was a trigram. I don't remember what was
exactly. So what the hell is that memory? If not,
right. Now, do Alzheimer's people, do they forget that there was a trigram to begin with?
it depends. It depends on whether they have like true anterograde amnesia by then. At the early stages, no. You don't. I don't think so. I sometimes call it intermediate memory. It's not as well studied, and the reason for that is. And the reason why I don't believe in short-term memory is because it's too convenient. Because the reason why we believe in short-term memory is because there's this neat tool that you can use that has this clear drop-off, and you can say you can remember this many items, and so lo and behold, it's harder. It's harder to measure stuff like what were we talking about? Sometimes you'll get it, sometimes you won't. Whereas with the memorizing of trigrams, like if somebody has dementia, you will find consistently they're not able to remember more than 4 numbers. Like that's it, and it's solid. And you can hang your hat on it. But for stuff like what you're talking about, will they remember that trigram? Much harder to do that and to capture that because it's hit or miss, and it's contextually dependent. How important was that trigram in the conversation, and all of that stuff. But at the same time, I think you have the same intuition I do, which is. I don't know if I have intuitions about neurons, but that's probably not a fine tuning of the model. Like we're not rewiring our brain to do that. There's something happening that's more dynamic that's going to go away. Like there's not going to be much of a trace of that at all past this conversation, or, well, now that we've talked about it so much, you may remember this for years, that trigram example, if we're really lucky. But chances are almost all of this will be, lost, except for like the distilled kind of basic semantic content of what we talked about, which I think does go into long-term memory, which is fine-tuning the weights.
I think what makes long-term memory, what allows information to get baked into longer-term memory, is going back and putting your attention on it.
There's definitely good evidence for that. Rehearsing it, paying close attention to it, all of that. And again, one way to think about this is dynamic versus static. And so a neural network is a static system. It has its weights and nothing happens to it over the course of using it. Nothing changes about it. It just defines a function. But during a conversation with an LLM, there's a dynamic process that's happening. The autoregressive process is dynamic, and there is dynamic memory there that's being formed due to this particular conversation. And once it's over, it's gone. And some of the stuff in the newer models, past a year or so, you can go and take some of those and store them in long-term memory, not in fine-tuning the model, but storing them. But in our brains, the dynamics is dynamic, and as the name implies, it's probably literally there's not any, the information is just not contained there anymore, past the conversation. But then there's this other thing that we have, which does has the ability to regenerate and to recall events that took place 3 years ago or whatever it is, a few hours ago. We were like, I remember that conversation. It's not in the dynamics anymore. Probably.
So I'm curious. Then it sounds. I'm going to say what I think you're saying, and then if you could tell me if I'm stating what you're saying incorrectly. Are you saying that short-term memory, although I know you don't like that term, but sort of the context buffer for autoregression is self-modifying in the same way that LLMs have this technique called prompt summarization, where if the conversation gets long enough, they'll go in and say, all right, what are the most salient points for continuing the conversation where it stands now? And then they'll sort of
feed those into the new prompt.
Yeah, but just create a new prompt. So let's say there's 8,000 tokens of conversation. It'll say, I want to compress this into 2,000 tokens of just the most salient points.
Yes.
Are you saying that a similar thing is happening in the kind of context buffer where it's not just static, but there's some sort of like self-modifying loop within the context buffer itself?
So what I'm saying
what is most salient and continues bringing it forward?
That is one possibility. I don't know. There's a couple of possibilities. The wilder possibilities is there actually that we have this very, very large context buffer. We just don't realize it. And we're being influenced right now by things that happened a long time ago dynamically, but you can only tease them out by sort of seeing how it influences us. But it's really there. It's much bigger than we would think. An alternative one is something along the lines of what you're saying, which is that it's actually considerably smaller in size, whatever this buffer is. I hate to use the word buffer. I don't think it's probably not the right, probably not, maybe, whatever. It's a useful term. Even if it's a buffer, it doesn't mean you're retrieving stuff from it. It could just be guiding generation. It could be much smaller, and you're doing this kind of summarization type of thing. Maybe that's what's going on. I don't know. I think probably the latter. Right, most likely is that we're towards a source of self-summarization along those lines. I actually built a model just like that: short context window, summarize, and it does a pretty good job. Summarize and then keep updating. Much smaller than your standard, current chat models like Claude, where they have a limitation. I assume, I don't even know if they're doing self-summarization. I'm not sure what they're doing. They don't tell you. But I kind of built what I wanted to try out. What if I make the context window really small? What happens? I think I mentioned this in the Polymath talk, the panel. And if you make the context window small enough, it will start to obviously lose coherence, and so it will be really crappy. And then I said, okay, well, what if you just summarize and then stick that into the shorter context window, and it does a lot better, obviously. And so I'm like, okay, maybe that's a model of what our brains are doing. Maybe we have a pretty short context window, if you want to call it that, and we're doing self-summarization. The only reason I don't like that is that it just seems very like hand wavy, and like maybe it's doing that, but we don't actually have any reason to. We don't have any evidence whatsoever that our brains are doing any sort of summarization like that. Like, I mean, maybe we haven't looked to see that.
Again, data chunking.
Yeah, it is kind of like chunking. It's very much, and data chunking you're saying is kind of a form of that self-summarization. Huh.
There's
You know what?
there's also
That's
this whole research on salience where sort of salient things that continue to be relevant to your immediate situation stick around, and the salience has a lot to do for how heavily it modifies the weights. So there is a lot of research on salience, and then the entrainment. Entrainment just means sort of, when I remember this thing, these neurons are activated, and that's consistent, and those are the neurons that were activated when I first saw it. And there's this whole research on salience and entrainment and consolidation, and those would seem to be mechanisms that are something like some sort of well-validated mechanisms to modify this context buffer.
Okay. Yeah. No. These are good points. I will steal them for my theory. But I'm kidding. You guys should jump on the train. This is definitely along the lines of where my own current thoughts are on how you could potentially do this, and maybe they could have really good analog human experiments. Maybe they're already in there in the literature, but maybe there are. I'm hoping that there are some pretty well some human experiments that would have clear predictive power, so that you can distinguish between these different theoretical frameworks. So something like, these are a perfect example. Like, according to this theory, that you're summarizing that it should have certain kind of outcomes in the context of just regular conversation. And this is why the reason why, again, I think this different theoretical framework is potentially experimentally testable, is because it's not about just retrieving, right? It's about guidance. And so you'd make very different kind of claims about how things will guide your future conversation or what you say or things like that, than if you're just thinking in terms of strict retrieval. And then you could think, because for retrieval, then you can't really talk about like saliency over a long period of time. It's not relevant to the classic paradigm of short-term memory, where you're just memorizing stuff. It's in terms of guiding generation, you could have much more subtle influences, and saliency may be an important factor. Chunking is a classic short-term memory phenomenon. But I have to think about it a little bit, because it is a great point that people do it sort of naturally, and it's the kind of thing that does show up in classic retrieval experiments. But maybe, as you pointed out, Dugan, maybe that's actually what we're capturing there is not retrieval, but guided generation. But you're seeing that summarization happening in real time. So that's a very cool. It's a cool thought.
Yes. Any remaining thoughts or ideas?
We've covered everything.
Everything that's ever to be covered ever.
Yeah, that's it.
We've solved it
Hang
all.
it up, guys. Hang it up. We've
Theory,
solved the
hurry.
brain. We've solved everything. There's not
We
really
solved
much
it
work.
all. We solved
Yeah.
it all. All right.
So I posted both of those links as a nice book into the conversation. It's kind of like how Netflix gives you, like, if you like this, you might also like. These are two theories of cognition that have a lot of similarity. They both say that sort of retrieval and generation are two separate processes. There's this, and maybe retrieval isn't exactly retrieval in the sense that we talk about it, where the exact bytes for this piece of information aren't stored in your brain anywhere. There's something else, and that something else, the goal is to generate things later. So it's the information representation is based around generation. At any rate, I could talk a lot about either of these, but they ring very familiar to what you're talking about, the idea of cognitive maps and Levin's sort of bow tie, what he calls this bow tie theory of cognition.
Wait, so you're saying that like sometimes ideas are compressed in the brain, that you have smaller representation that when you access it, it'll sort of generate up the dot that was there?
Yeah, so both of these theories kind of say that there's not separate processes for retrieval and generation. There's sensation or information in the brain that's stored from sensation, and there's sort of a compression that happens, and then it compresses to a very high level abstract representation, and then sort of unfolds itself into whatever it's generating. So it's basically saying sensory, for me to like pick up a glass of water, I'm going from complex to complex. I start with something very complex, which is this whole visual field, which contains a lot of things, and I have to identify where the glass of water is. And then I end up with something very complex, which is moving all of the muscles in my arms just the right way to pick up the glass of water. And so what this is saying is what's happening is that complex sensory input is sort of increasingly mapped onto more and more abstract representations until it's an extremely abstract and extremely compressed representation. And then that's the way that representation is optimized is whatever is going to generate my action the best. So that representation is sort of unpacked into my very complex action. And it's saying the same thing happens with memory. And so memory is just kind of, I have these abstract compressed things that are good for generating action that are stored in the brain.
Again, with the chunking.
Yeah, with very similar to chunking. I think there's another piece that you're missing though, Dugan, of consolidation here. Or abstractification, something like this. I don't think pure chunking will get you all the way there, but I like where your head's at.
Me too.
No, I was gonna say like you know, a lot of times when I think of things and I'm trying to combine them, which in a sense is sort of how they're being chunked, right? Like how are they compressed under some because you know when I think of abstraction is I basically think it lets you to have one lens of viewing multiple things. I think that's really all that abstraction is. I think abstraction is basically how can you have one shared view of multiple things, right? Because you know when you abstract things is you're trying to find the connection between these things that are kind of somewhat separate. And so a lot of times when I actually think about the kind of the idea or the intuition or whatever is like, I have to purposely think of it in a specific format. It's like, you know, when I come up with an idea or something, like a lot of the times it's like, well, this depending on how I express it in my head, what language I use to express it in my head, it could look like, you know, it could look like a book or a YouTube video or a salon or a product or a service or a song or a painting. Like it sort of, I sort of seem to have this thing where I can translate it between all these different mediums. And I know there's other people that have spoken about this thing before. I've heard a lot of this from artists, actually, interestingly. And, you know, I don't know if it's necessarily, you know, people who are maybe naturally more interested in the arts have this, or if it's something that's also kind of trained over time. But the other thing I'm going to tie that into is like a lot of times what I like to do is like, you know, I like to design and I like to do all that type of stuff. And, you know, like I'll look at like a car and I'll take over some very specific memory I have of a wooden object and I will try to apply some qualitative aspect of it to the car. So like I'll have the texture of the car become wood-like. I'll have the tires take on some visual element from some other thing. It could be like a table. I could be, you know, at a restaurant or a cafe, I have like a wooden metal table, some kind of wooden brutalist type of thing, and then a car driving by, and I will sort of consciously, actively go and, you know, lens on the, you know, those material texture things that I see visually on the table onto the car, and then I'll take other things about the shape of the table and, you know, almost multiply and add that onto the car, like you're making some kind of transformation. And that's different than what I think about like when I try to combine the functional aspects of it in the way like, you know, the way an engine works or the seats work in a car or the table, where I'm just dealing with the thing strictly visually. And so when we chunk things together, I'm very interested in finding a universal way of chunking that lets you do all of those things instead of just one specific way. I don't know if that makes sense at all. Nope, I lost you.
No, so chunking, you mean chunking functional with visual? Is that what you mean?
Well, so sometimes I'll think of like, you know, a table holds, you know, your food and your coffee, and the car holds the people, and then, you know, the thing that's kind of common between them is that they're both utilizing a person to hold something in, you know, inside of the thing, whatever. And I'm saying separate from that is visually, I can think of like the things that are visually contained or projected onto that. Right? So designers, a lot of the times when they mix materials and textures or colors in their head, is they're applying something from one thing and applying it to another. They're kind of translating between those things. And what I'm saying is, you know, under autoregression or just in general, is there some way you can chunk all of those things together under one thing? Like you can just look at it that way and all those other things are implicit. Right? Because what I think intelligence really does when we talk about like general intelligence is you can have some type of lens or worldview that lets you, you know, play piano and do a math equation, learn a language, and design on a computer. And you don't have to change anything about your mind to do that. I don't know if that's clicking more now. I don't know.
So I'll say one thing, maybe before Alon speaks, cognitive maps would sort of seem to show a mechanism for the synthesization, and that they're all about integration across sensory input, so kind of dimensionality, time, and space. And so sort of, I have many different senses, and I have to get a holistic picture of the world from all of them. So if I'm like having beers with Alon, I'm tasting things, I'm seeing him, I'm hearing things, and I sort of have to integrate all of these. And so cognitive map says I integrate all of these as sort of, all right, I'm drinking beers with Alon. It also says that I'm integrating across time and space. And so I sort of have a cognitive map for here's our previous conversation and here's a conversation before that. And I have in some cases, I can have a cognitive map for space. And so this would, I think the answer the cognitive maps theory would give is that compression is synthesization at a certain level. And then when you generate from that
I can agree with that.
compressed representation, then you have to generate something that's synthesized because you had to put all of these things together to compress it to the degree that you did.
I don't know if I have much to add to that. My mind is going towards the earlier comment about abstraction, and I'm not sure exactly how it relates. I think it does. So I think of I'm going to be accused of being like ridiculously narrow, but I think the process of abstraction, I think, is a purely linguistic one, but not a purely linguistic one. So let me explain. Like when I say when I have let's say I see a ball and it has a bunch of properties. It's a red ball rolling down a hill, and it has a very specific, immediate sort of sensory kind of qualities. When I say there's a red ball rolling down a hill, none of the qualities are besides those exact ones that I'm specifying are carried in that information. And what I've just said to you right now, you can have an image in your head of a red ball rolling down a hill. Each one of you has a different one. And so what we've done in the process of what I've done in the process of turning into language is we've abstracted away from any specific sensory specific experience into something more general, which then I can input into your brain or in somebody else's brain, and we'll run something that will end up having sort of a sensory, some sensory expression. But it's very different, right? Your ball may look totally different than my ball. The hills, I have a rocky hill, you have a grassy hill, whatever the hell it is. There is no hill in there, right? It's just a particular. That's just a very specific that your brain has to do to get its sensory, has to go to the concrete specific. So there seems to be really a very strong relationship between linguicizing something and abstracting it, and then how that I think it also is related to Addie's point about synthesizing, because you do it across modalities. You talk about a multimodal event. If I say, imagine yourself and you're in a crowded club, with tons of people at a party, it's going to have smells, it's going to have sights, it's going to have all of that stuff. That little thought bomb that I drop into your head, boom, it activates all of this multimodal stuff. And so in the process of remembering stuff and in particular in the process of having to communicate stuff, we do this kind of abstraction where we take the concrete, that are subjective, specific experiences, and we turn them into I don't know if I want to use the word objective, but it's kind of like that. We turn them into thought forms, into words that then can be dropped in somebody else's head and produce something that's not identical, right? But captures, at the abstract level, captures the same sort of basic meaning. And so I don't know if that's related to all these points, but I've definitely been thinking recently a lot about abstraction as being inherently a linguistic thing. We can't there's no abstraction in the sensory perceptual domain. There's no such thing. Every single sensory experience is highly concrete, fully concrete. It's just that experience. And then from there, we go and maybe I guess you can abstract away, like I'm looking at this desk, I can imagine the desk from another perspective, but then I'm just running sort of like, here's another concrete experience. But when we talk about a desk, like the word, that's an abstraction, right? It's an abstraction in the sense that there is no specific concrete sensory experience that goes along with it, and yet it has the linguistic meaning it does. And it also has this effect that if I drop it into your head, you're going to get a specific desk in your head. When I say desk, boom, you've got a desk. I don't care what I don't believe if you don't disagree, right? Unless you're aphantasic, you're going to have a specific desk. You can tell me what color it is, probably. Now, it's not the same one that Daniel doesn't have, the same one that Dugan has. But that word desk, as an abstract concept, then plays back and generates concrete sensory experiences. So I feel like there's a lot there in relation to this idea of abstraction and synthesis that language is doing. And again, I don't mean to always harp on the language piece, but I really do think the language is doing this thing, this communicative thing, which is this dance between communication or coordination and the sensory, and it seems to be very related to this idea of an abstraction. Does that resonate out of, that was a diatribe. Does that mean anything to anybody? This idea that language is abstraction is inherently linguistic. What about that claim? All right, do we have abstractions out of language?
I think so.
You think we have abstractions outside of language?
Because there's evidence that things like hippocampal ripples seem to encode a entrainment pattern in a more compressed fashion. And that you lose it's a lossy compression. So you lose some information in that compression, but you keep the most salient parts. And so I would argue
you lose
that
information doesn't mean you're getting to an abstraction, though. Because like the word desk is an abstraction, right? Whereas the hippocampus, what could be happening there is like you no longer remember exactly the shape, but you've got a vague, fuzzy version of the shape or the color or something like that. But desk doesn't really mean anything sensory. You're saying
category.
Yeah, it's category, and categories are, well, that's an abstraction. Unless you think it's, unless you think it's sort of average or something like that, but nobody believes that.
Would you actually say that? Go ahead.
I'm saying that there's evidence that there are neural patterns that point to several different things in the real world. So this is what's called polysemanticity and monosemanticity.
Cool.
And there's evidence that as the brain compresses things, it relies more and more on polysemanticity. So sort of, I have a desk and it's this specific desk, but as I remember the desk and those hippocampal ripple happens and the consolidation happens, that's going to become more associated with sort of the polysemantic neurons that represent all desks in my brain.
Interesting.
And so there's good evidence for polysemanticity in that our brain compresses things in such a way that we get more and more polysemantic neural representations. And polysemanticity is a lot like abstraction.
Maybe this is all wrong. I mean, like dogs have a concept of dog, because I can tell because my dog goes crazy whenever it sees a dog. But those dogs all look so different, and it's never seen some breed of dog, and it's like, that's a freaking dog. So it seems like it sort of doesn't need language in order to have the concept of dog. So yeah, maybe language gloms onto that rather than thinking of language as being the anchor of abstraction. Maybe
I was gonna say is language itself kind of observer dependent, because people will talk about, we get our perception of physics or mathematics or all that is that's the nature of us as, you know, the types of observers that we are. And I wonder if language itself is kind of, we have this idea or notion of language because of the limitation for ourselves as observers, and there's something kind of beyond that that we are not really picking up on. And then, you know, the fun question then is observer dependency also observer dependent?
Observer dependency. So would language be a way to transcend observer dependency?
Well, I'm saying
Yes,
is everything, you know, everything that we think about with language right now, that is that sort of a limitation of ourselves as the types of observers that we are. Like the entire concept and notion and framework and the way we think and communicate is that, you know, about language, right? And all the models we made on is the entire chunk of language itself just sort of this limitation of something bigger because of our you know, constrained nature as observers.
Right. Oh gosh, that's a head hurting one to think of. Like what?
Because remember,
Yeah,
I always tell you, it's I'm obsessed with the unknown unknowns, and I
No,
know
I gotcha. And you're like,
yeah.
yeah, right. And right, yes, I'll tell you firmly that we are not good at at conceptualizing what we can't conceptualize. I think I can say that with certainty.
Right.
Right.
Dugan,
That's
I want to know your
logically
thoughts.
true.
You want to know what?
Yeah, no, Dugan, I was talking about, you know, this, we kind of don't have, you know, people will sort of say how we have, you know, the mathematics that we see and interact with and the physics we see and interact with, you know, whatever we get out of physics and math or whatever is because of the nature of our observer, right? How limited we as observers are. And it's kind of an artifact or result of that. And I think language itself is also a result of the fact that we are limited observers and there's something else potentially, you know, larger, whatever, that's an unknown unknown that, you know, if it's restricted in a certain way, it looks like language, right? And language, including all the different frameworks in math and logic we have behind language itself. And the fact that we can use language to even talk about that.
Yeah, that's what's wild. Or to talk about that, we can't talk about it, at least.
Correct, exactly.
That, yeah, what's the set of all things that language can't talk about? Well, we just talked about it.
Right. I mean, what's
Yes.
the set of
Well,
all
that's
things
it.
that, you know, symbolic computation can describe? You know, there's all sorts of symbolic manipulation that is like foreign to us. It is computational, but not sensical.
Not sensical to us.
To us, at least. Yeah.
Yes,
Well,
these
also,
are.
like things seem like they're nonsensical or chaotic or noisy until we understand them, right? Like, you know, I think that whatever we consider to be illogical, nonsensical, crazy, whatever, are just things that we can understand, and then that to us looks like, you know, what we'd call crazy or nonsensical or illogical. I think even if you say, you know, as Will would say about, you know, drunks and babies and language or whatever, is that I think that's completely, I think at least that is in part a result of the way we're looking at things and perceiving things, and so we attribute that label or category or abstraction to that. And I think, you know, if you, again, this kind of comes from my cognitive modification side of things, is that, you know, if you really try to get into the headspace of people that we would consider to be crazy or I mean, I don't even mean like clinically crazy or whatever, right? We can even say that, but even just people that we consider to have, oh, this is just a really dumb idea, this doesn't work, whatever, is that if you can really get into their headspace and feel it as they do, you realize that your sense of logic and their sense of logic is the same. And the thing that's showing the difference is the disagreements of the way you're expressing it. And it's not saying that, oh, anything could be anything, you know, I'm not saying that. But what I'm saying is I think our understanding of what is accurate or not accurate, logic or not logic, language or not language or whatever, is really just, we're too limited in our view. And the way that looking at this is useful is because, you know, it's one thing to say kind of as a, you know, as a psychonaut philosopher to go and talk about this for hours on end and make a Terence McKenna, you know, style lecture on it or whatever. But, you know, for me, the thing that's kind of useful, which also is also observer dependent, but if we're trying to kind of try to squeeze something larger into this smaller view of ourselves as observers, as limited minds, is that I think we would be able to, first of all, understand people better if we could just get into their shoes, like a method actor. I think that's partly what a really good method actor is doing. But I think more importantly is that if language is our kind of limited interface of something larger that we can't directly tackle with, how can we modify and redesign it to better be able to allow us to infer these differences in experiences? Because just before we were talking about, like, how do we actually know our experience of the color blue is the same? Or when I tell you about some crazy meditative or psychedelic experience or whatever, how can I actually use language in the way that we use now to infer what that actually feels like? All right, you could say that's like some type of a experiential computing, quality computing, emotional computing, whatever. I'm sure Andres, I'm sure I could have some comments for that. But I think if language is kind of what we're at least restricted to for now, forgetting about theorizing about what else is outside of that, is that I think it can be a powerful tool for us to communicate these ideas more effectively, and not just the idea, but the actual experience, right? Because we have no problem saying, if you look at a certain photo, you'll feel a certain way. If you listen to a certain song or whatever, and you can feel really sad or depressed, but you can also feel really energetic and excited. We have no problem saying that those sounds lead to that. Why is it that when I'm talking to you right now, I also can't have a similar effect of getting you to experience what I'm experiencing? Can I use language to actually get you to, at least in some sense, experience just enough of, say, some other cognitive state, whether it's sleeping, dreaming, some disorder or whatever, to get you to understand that? Because then if we can really understand that, we'd be able to know how to help people. Right? Is that a lot of the times it's communication differences. Like, it feels like we're talking about the same thing, but we may not actually be. And so I'm just wondering how you would tie this into the whole representation thing with language and LLMs and autoregression and all the stuff we've been covering today.
Well, personally, I'm a little pessimistic because I feel like language doesn't really express any inner subjective feelings. It has the power to, the capacity to trigger known pathways of experience. If I say to you, picture a red, like I said, picture a red ball or something like that, it can certainly activate the same pathways and mechanisms that probably get activated when you're actually seeing a red ball. And so it has a capacity to kind of, to just at the superficial level, it can sort of do a handoff and say, hey, sensory system, produce this thing that you already know how to produce. The capacity for language to go beyond your existing set of experiences, I think, in my understanding of how language is working, which of course, this is very limited, but it might not be able to do anything besides that, right? To just harness existing already pathways that have already been set, and sort of just associatively, rather than say, can I get you to somewhere else, right? Experientially with language. I think that's what poetry sort of tries to do, but it doesn't. It's hard. Poetry is very, is inherently kind of difficult, and I don't know how well it really does it. But I think the existence of poetry is a reflection of the fact that language doesn't really have this capacity to share an experience, right? It's show me, don't tell me, right? That's the whole point of poetry, at least classic poetry. I'm not talking about very, kind of modernist poetry, but like poetry that's really meant to be evocative. It's like, because what it's able to do is cause your mind to experience things that are sort of already locked in there, and it's triggering them. But you're talking about a kind of like an almost what's the word? You're talking about like an expansive version of language or poetry that gets you to states that you otherwise you would need the actual experience to have, right? You never had this experience.
And on top of that, that ability to kind of infer the thing is that when people are on some kind of substance or whatever, and when I say substance, I mean you can take something, but there's also ways of kind of somewhat inducing this in a sober state. But the reason it's interesting to me is that, you know, people will often describe that they're able to better experience what the other person is feeling if they're on a substance together or whatever. Like now they, like, I make a joke that I never really understood trap music until I had tried lean. Like it just never hit, like I got it. Like I
Sure, I mean,
really,
that's the entire the Grateful Dead.
really
The
got
entire it's like the music sucks unless you're on weed. That's everybody says it.
right. Okay. But why is that though? Why is that? Right. And
Yeah.
it's like, are there, you know, when I talk about your sort of subjective lens, that way of lensing your experience or whatever, is that how much of, you know, what we're doing, and I don't mean like, okay, obviously we should be talking in the same terms to be able to understand each other, whatever, but is there sort of another element about the actual kind of, again, I don't even know the right words to use for this,
Yeah,
ironically.
there lies the problem. Yeah.
Yeah. There lies, exactly. There lies the problem, right? Like I can understand. I've just noticed if I'm sleepy or if I've taken a substance or if I get myself into a certain state, I can just understand the thing better. Like it just makes sense, right? Like, you know, when you're playing a sport, we're not thinking like how we are right now.
Not at all.
Right. And again, I think that's still, dare I say, you know, that's also its own kind of language in a weird way, or something more abstract and general or fundamental. I don't know. But there are all these different ways of, I think, representing information and communicating that. And I think language is kind of just representation and communication, at least in a very kind of general way.
Yes.
And I guess, again, my point with all of this, right, is that like, is how does this kind of help us with diseases and all these things? Because I think a lot of the time, you know, if a disease is causing an issue in your life, the only way of making your life better is not necessarily only getting rid of the disease, right? You know, if it turns up that it's more difficult to get rid of the disease, you'll find another way to compensate for it. That's what life does. Like I give the example about, you know, let's say you're right-handed and you screw up your right hand in an injury or whatever, and you can't use it. And if your body can't, you know, doesn't have the kind of, you know, if it's constrained and it can't, you know, regenerate and heal your arm right away, well, what does it try to do? It finds another path. It'll go ahead and find maybe a way to use your left hand or your hand or your, you know, your legs, your feet or whatever, or some other thing. Or you may find something, some tool, an extension of your body to invent and remix in the environment to also serve that same goal. That's what we do with all of our tools, right? And so my kind of big question, again, which also ties into the unknown, the things that we're missing, whatever, is that are there, in terms of diseases but diseases in general, right, is that I don't know if the only way to make people's lives better is like I think people get attached to, okay, you have to remove the disease. And I know we talked before about, are there maybe optimal levels of diseases in the body that actually keep the thing healthier in the long run? That's another topic. But what I'm saying is that there are certain things that we consider them to be a disease from our perception as observers. But trying to get rid of them would cause more of an issue than if you were to leave it alone and focus on something else to overcompensate for it. Right. And at the end of the day, when you the reason you don't want dementia or whatever is you want to be able to function to this specific level that we describe. Right. That's really what we're after. And, you know, are there ways that we can have these, you know, conditions in the brain, whatever, but we can still function optimally or even better? It's just a thought experiment for now, because there are people, for instance, you know, we consider, hallucinations to be bad. Well, guess what? You know, we hallucinate every night, a lot of us. Right. And some of us also will hallucinate during the day. I think dyslexia is an almost type of hallucination. If we missee things or mishear things, that's kind of a hallucination. But on the extreme side, there are people that do experience these sort of, you know, which will be a topic for another salon, but these tulpas, or these sort of hallucinated different aspects of themselves, or they'll see demons and angels and shapes and colors and all these things that are technically not there, but it doesn't actually interfere with the way they live their life. And if anything, sometimes it gives them an interesting perspective on things. And so I wonder, are there ways of experiencing the world where the disease doesn't cause you an issue? Like, I mean, an actual qualia of experiencing the world that the disease does not cause an issue.
So you talk about to use an old-fashioned phrase, like talk therapy, but not in the classical Freudian sense, but like, is there a way to, and using, like, I mean, you had originally mentioned language, but maybe other techniques, but sort of modifying the way, the modifying experience, but not necessarily through any sort of substance intervention.
Right. I think there are probably ways you can experience the world that doesn't make the disease an issue. And there's multiple ways that your body and mind will try to get rid of the disease or overcompensate for its presence or whatever. You know, something I can think about is like when we just say we ignore things. Like if something is irritating you, you just try to ignore it as much as possible. I'm not saying, oh, you ignore a disease and it'll go away. I'm not saying that. But what I'm saying is there sort of something experiential about, you know, if you look at, you know, let's say you look at a disease as a kind of, you know, whether it's dementia, cancer, whatever, is that this is what your mind is perceiving of something. Can you remove that perception? And I don't mean remove the perception and it's still there and then you don't feel anything and then it kills you. I mean, is perception tied enough to the actual thing that by removing the perception of it, you may be able to at least dampen the effects of it, right? And again, this sort of ties into that placebo thing or whatever. It's like, yeah, you can, I do think there's something there. Do I know if you can cure everything from it? I don't know about that, but I do think there is something. Because in a sense, if I tell you right now, you know, just by making a couple noises, I can get you to go up to your car and drive somewhere. By just making a couple of noises, that's it. A couple of noises with this meat box on my head.
It's a great point. It's a great point.
Right? So I don't know. That's kind of where I was getting with this thing.
Yep. And just telling somebody that you have cancer or that you don't have cancer, has dramatic effects on surely on their health outcome. So how much? Yes, I love it. I don't have like anything constructive to say except that it's certainly a very keen observation that. And you've made it before in other contexts, which is that the mind is certainly highly manipulatable, even just language just being a good example of it, but surely not the only one. And so where does that leave us in terms of thinking about, you know, people have, of course, therapy is a thing, right? And that's primarily just trying to use words to change outcomes for people.
Correct.
But you're talking about, I assume, something beyond the current
right
kind of palette of therapeutic devices. How much more radical could we go?
Right.
Well,
I mean, my you know, to make a joke out of it, my observer dependent perspective on this thing is that this is observer dependent. I think all these things that we're seeing are the way that they are, and they seem to us because there is a fundamentally limited aspect of our minds and cognition. And the thing is I don't even think this is my attempt to transcend it, which if it's correct in a sense you probably can't, but you know, see this gets really recursive and tricky, and sometimes I think it's just not useful, but bearing with me at least for a moment is that I think that you know, I've said that I'm very focused on diverse forms of cognition, right? I think muscles and bones and all have their own cognitive properties. I think the hormesis thing is basically learning just in a less conventional way than we normally think about it. And I think the reason that we don't see them as connected is because the way we observe things is limited. We see things as sort of separate until we find a way that they connect and they're compressed or abstracted together. And I think when we say they have a higher general intelligence or whatever, is that they have a way of experiencing the world that lets them see all those things as one. And the thing, you know, an exercise you can even try yourself is like, you know, you can think of some word or whatever and read an article under that. So, you know, I'll talk about like, you know, if you look at a thermodynamics paper on Wikipedia or on a journal or whatever, and if you read that under the lens, under the interpretation that it's talking about behavior and cognition and mind or whatever, that actually does end up reading exactly like the free energy principle, right? And it turns out though that if you take, it's not necessarily as much the specific lens that you're viewing things under, it's the fact that you're sharing the lens. So when I talk about the synesthesia thing and all these things, is that, yeah, I can look at, when I read a paper, it could be mentioning sound and waves, but I could be thinking it's talking about color and emotions or whatever. And I can get similar end results, powerful end results and predictions. It's not that I could look at it as if it's talking about shapes and food. It doesn't matter. But as long as there's continuity between what I'm observing, then I think you get that same power and that same result, right? And I think that's an aspect, because when you're solving a Raven's progressive matrix or a number sequence thing or whatever, you're distributing an aspect of your cognition, your experience, over those multiple things until it finds something that then it doesn't have to continue changing itself. It can then look at it as, okay, these are all under the same view. I think that's experientially what we're doing when we are kind of learning those things. And actually at one of the dinners, I don't know if you were there for this, but I was talking about, before I get to Jesse's comment and his questions, but I was talking about, actually, DVZ, I think you were there for this, but one of the things, actually, no, DVZ and Dugan were both there for this. I don't know if they heard it, but one of the things that I was thinking about, there's two things. So the first one is, what is the quality of neuroplasticity? Like, what does it feel like to view things with a brain that's more plastic, right? And I think you can get into that. I think, my answer to that, as part of it, is you're viewing things with a bit more ambiguity, because the moment you choose how to view something, you're already limiting it in another way you could see it because of those restrictions as an observer. So I think part of of inducing neuroplasticity without taking a substance or whatever is that you can get yourself to just view things more ambiguously. And so then you can sort of have a bit more freedom to learn and choose how you're interpreting the information, right? Which is, again, maybe we can name a whole salon after that. But just something to think about is the quality of neuroplasticity. What does it actually feel like? The experience, the day-to-day, second-to-second experience of feeling more plastic, right? And then the second thing is, I was talking about, we talk about tools and fire and all that stuff. And I was telling someone, I said, how was fire actually invented, right? Was it just, people stumbled upon it somewhere or whatever, or like, I'm sure fire was kind of independently derived and discovered in various different ways throughout history. But, just as a thought experiment, as a simulation, if you were to, throw a bunch of humans or animals or whatever into some restricted setting or whatever, how would they rederive fire, right? So, what sort of abstraction or goal do you have to come up with to invent fire, of all things? Because you're talking about inventing something that you don't have anything to relate to before from your perspective, right? Okay, yeah, there was this Bernie was on this branch or this tree or this leaf or on the ground, or these rocks kind of hit together in a certain way and it seemed to have this effect or whatever. But if they didn't have any of that, how would they then come up with fire? And this is not, it's fun to think about from a historical standpoint and sort of anthropological standpoint. But to me, I think there's something about cognition that's super powerful about this. Because if we can understand how that works, then imagine what else we could come up with. Because right now, maybe we're in the position those people were when they came up with fire. And there's so much more that we just haven't thought about yet. So my question to you then is, thinking about this thing about fire, right? How would you, if you never saw the fire, experienced it before or whatever, is how would you actually come up with a concept or goal where you need to create fire? This also is tying into that thing about the way you're saying sort of LLMs experience and represent information.
I don't know if we're going to be able to reinvent fire in 8 minutes, but I think you're raising definitely profound questions about sort of the extent to which we're trapped in our conceptual frameworks. And I do think, just bringing language back into it, that's our medium for, I guess you could call it communication coordination. But how much have humans tried to expand? Certainly with substances, humans have expanded and their sort of cognitive framework with literature and I said poetry. But what you're asking is, are there unexplored avenues for expanding our conceptual frameworks outside of those? not that have been tried before. And I don't know. Could we invent new languages, like synesthetic languages, or whatever? What other language? This one way I think that's a really interesting question is just how constrained is language? Does the form it has and the structure it have to be there in order to have its efficacy, or is it just this is how it's played out historically, and there are other ways to conceptualize language such that we could maybe convey experiences more effectively, like subjective experiences more effectively in a way that or modify experiences like you said earlier, and if we could do that, could we come up with other ways or other languages? I guess Will Hahn's trying to work on Soresol, which is this musical language. You're asking
Or
a very
the olfactory language. Or the
what?
olfactory language. The olfactory language.
Olfactory language. So the fact that language is so extraordinarily powerful in in coordination, B, in thought, and all of the stuff that it's able to do should give us hope. It's definitely an artifact. It's made up. It's not the world doing it to us. It's something that we have that does stuff within us, but it's made up. Can we make up other stuff? I guess is sort of the question that you're having, right? And without substances, just doing the kind of stuff that we do already, making sounds or patterns of sounds. We can do all kinds of crazy things in each other's brains. Have we begun as a species to explore that really? Like, should we think more radically about that extraordinary power, especially now that we know that it's this kind of autogenerative system it's clearly some sort of computational artifact that has structure that's meant to do stuff rather than just an accident of sounds associated with other modalities. So I think it opens the possibilities. It's as vague as that sounds. I mean, it was a very broad question. I'm giving you a very broad answer. Are there other ways that we could affect each other's brains without bashing them in or filling them with other gunk that's not supposed to be in there, but doing it linguistically or quasi-linguistically, some other kind of trans-linguistically or something like that? It's a fascinating idea. I've never really thought about it, but it's definitely worth thinking about.
Awesome. All right. Any lasting thoughts from DVZ or Jesse?
To try to add something before I go, I do think there's something to what I haven't been to more of these. I'm kind of understanding more what Addie's like trying to get at in some of these things, and I do think there is something to kind of. I was writing this comment in the text about fire and like, at that level, like you have to be able to interface with it at a bite-sized level before you even see what it is. Like seeing something in the world and thinking, oh, it's too much fire is like bad news and you might die, and the right amount of naturally occurring fire from lightning or whatever or something generating it is another thing. So like being at the sort of zone of proximal learning of interfacing with it is like that came up. But I think to the broader point of like what I'm understanding Addie to get at is like all these things where in the hormesis sense or other sense of like what can we do to kind of first principles it back and see, okay, there's all this structure that lends to this, but is it observer dependent or not? I really like I'll try to go back and see the bit about shared lenses, because I think that was something that I would re-emphasize too. It's like I think a lot of it is just the orienting of being on the relative same page or like trying to get a similar vantage points. And I have this essay about vantage points that I should talk to you all or Addie about, whatever. And I think a lot of it is like there are vantage points that clearly exist, but no one has built scaffolds to actually transmit information from. And I think that's kind of there's a lot of reasons why certain vantage points have existed so far, and like why language developed the way it is, and so on and so forth. But does it have to be that way? So more about that later. But it was very fun to hear everything today, and I hope for more discussions again when I'm a little more able to participate. But it's great to hear all this. Yeah.
Yeah.
I enjoyed it.
Yeah.
I'm excited to see how your theory develops along as it becomes more precise, and we'll hopefully get some hypotheses that don't falsify it soon.
Don't
falsify
Either way, right? I tested, but testable. Be great.
Yes, I used to say validate, but I had someone correct me on that recently and say hypothesis can never validate a theory. It can only not falsify it. So.
It's hard to do that either, but I hope that it can make precise enough predictions that at least falsification.
Awesome. All right. Any before we all say goodbye, does anybody want to promote their Substacks, YouTubes, Twitters, anything at all? Salon first.
Oh gosh, yeah, my Substack. I should drop it in the. Yeah, you can find some writings along the lines of this exact conversation today.
Awesome. I will drop mine as well. It is DanielVanzant.com. So my name.com, in case anyone's listening to this. Maybe by the time you get this posted, I'm working very hard on an article on research outcome markets which is scientific research funding is sort of in crisis now. And this is an idea I have on maybe a better mechanism for it. And so depending on when you post this, that might be out. And if it is, you should check out my Substack and read it because I've been working very hard on it. And I'm very excited about it.
I think I found your Substack. I don't know if it was you, but I look forward to that. I'm doing a slow but major website update, so it's just JessParent.com, JES Parent. And I have a Substack with things that are coming up too, but nothing super cool to show yet. But things will come. All right. It's good to talk.
All right.
Thanks, guys.
Thanks, everyone.
Thanks, everybody.
Take care.
Have a good one, everybody.
Bye.
Bye.